Probably there's no one online, yeah?
No, they calculated
They
at least
didn't
1.5 hours more.
They set their alarm for 45 minutes later than they
Yeah.
expected.
So you can stop time.
Yes. Okay. Hello again, and well, quite different than yesterday. We have today the effect of temporal subsampling on the accuracy of volumetric video quality assessment presentation. It's a paper that we published with colleagues from Trinity College Dublin on Picture Coding Symposium 2021. So in this work, we explore the volumetric video quality assessment and mostly on the temporal domain to reduce the complexity. And why we do that, I'll try to explain our motivation. So the volumetric video, for those who doesn't know, is captured basically with multiple cameras and image sensors that are placed in a green screen room, kind of like this. Actually, this is the real example. So these images and then turned into temporally coherent volumetric videos that are represented either by 3D meshes or point clouds. When rendered, they mostly pose similar visual experience. But the thing is, their representation is completely different. In 3D meshes, we have vertices and edges that contains the connectivity information of the 3D object, while in point cloud, we have no connectivity information between the points, and color information can be encoded on the points themselves. However, well, we can see that there may be millions of points, and for each given frame, we have to repeat this information, and this information can be really overloading, and this increases the importance of compression in this scheme, and there are quite high number of individual researchers that works on this subject to improve the quality of the content that we compress. However, this poses a quality reduction in terms of visual quality in most of the cases, and estimating the quality of this content also can be challenging because of the high amount of data requires a lot of calculations, even with simple metrics. So in this work, what we want to do is, can we somehow speed up these metric calculations without sacrificing from the accuracy of our quality estimations? And if we explore this via temporal subsampling rates with various subsampling rates and various sampling methodologies. And then under these varying conditions, which metrics perform the best in the tested data set. So we can categorize these metrics in this work into broadly 3 groups. First group is point-based metrics. So they operate on the point clouds, basically. I think all of the metrics here, point-based metrics are here. They are full reference, so they need to have access to the undistorted and distorted point cloud. And they just use the location information. And then color-based metrics that we named as color-based, they also utilize the color information that are encoded on the individual points in the point cloud. And image-based metrics or rendering-based metrics are basically metrics that operate on the rendered views that are also used in the experiment, subject to experiments. And this is, yeah.
Sorry to disturb, but what does it mean then a point? How you compare points without...
Just the location in the 3D space. In the point, there is one point cloud, uncompressed, the reference point cloud. You have, for each point, you have the XYZ coordinates in the 3D space. And for an undistorted point cloud, distorted point cloud, we have the same information for its points. And under these metrics, some of them calculate the distances between each point to each point in the other point cloud. And some of them operate from points to plane, and some of them operates from planes to planes with different distances. And they are widely used in the literature, and quite simple. It's like the basically MSC or PSNR of the point cloud world, I would say.
Thank you.
And color-based metrics are on top of this. They use the color information as well for to evaluate the quality. Yeah. So what we did here is also, of course, we tested these metrics, 30 of them in total, but also we tested different temporal pooling strategies. Like this was achieved by, when you think about it, this is a video, contains individual point clouds that one after another in each frame. So when you think about it, this somehow needs to be pulled into one quality score that represents the quality of the whole point cloud sequence, volumetric video. And for this, we use a pooling function normally. And generally, this is just taking simply the average of all the frames in the volumetric video. And also, we can use different number of frames. We don't maybe need to use all the frames in this volumetric video to come up with the final quality score. So we tested different sampling rates, so different frame rates. The original content in the data set, which I will explain briefly later on, is 30 FPS, 30 frames per second. So we uniformly sampled these sequences with 1, 2, 3, 5, and 6, 10, 15, and 30 frames per second. So in total, 8 different frame rates. And we used 7 pooling methods that we collected from the literature for video quality metrics that are usually utilized. Yeah, I'm not going to go into details on all of them, but the simplest one is basically the arithmetic mean. And the data set that we did these studies on is VSense VVDB2 data set, which is well known to many of you here, I assume. It contains 8 point cloud sequences, and some of these point cloud sequences are also they also exist in the data set at 3D meshes, but we on this study we solely work on the point cloud sequences, and they are compressed with 3 different coding algorithms, GPCC and 2 mode of VPCC, and each of them has 5 to 6 different compression levels. And they are rendered orbitally with an orbital trajectory around the objects. And then these videos was shown to subjects, and then mean of mean scores were collected. And we, in these tests that we are going to do right now with the temporal pooling strategies, we'll try to see the accuracy of the metrics based in comparison to these MOS scores in the dataset. So first, we wanted to investigate it, start with the impact of the subsampling rate, so different frame rates, basically. Here there are 4 plots for each one is for a given metric, and these on the x-axis they are the metric scores. So actually the values doesn't mean much here because they all have different scales, so directly not comparable. But on the y-axis, on the horizontal axis, let's say we have the frame rates, so increasing from left to right. What we expect here is actually, I mean, what we want to see here is actually we want to have similar scores for even lower frame rates. So the fluctuation of the metric score shouldn't exist for different frame rates. At least that's our expectation, to be able to use this to our advantage to reduce the complexity of the calculations. It is actually the case for color Y and SSIM, which is good because they have a higher performance. But the 2 other metric that has quite low performance, which we will see in a few slides, that they fluctuate quite a bit, which is not good, but also maybe explaining their low performance even with 30 frame per second evaluations. And when we check these are for all metrics, these are the metric score changes. And for some, there are, as you can see, some fluctuations exist, but for some, it's a straight line across all the frame rate levels. And this can be easily observed also on the correlation results we get. So on each column, we have a different frame per second frame rate, and it increased from left to right. And for each category of metrics, we put the higher performing one in bold font for ease of use, ease of read. And as you can see, even with 1 frame per second, the metric performance is not that different from the 30 frame per second. So this means that, well, at least for this kind of distortions that are uniformly distributed on the point clouds or on the renderings, we don't need to utilize all the frame rates to come up with the final quality. And when we check the temporal pooling, similarly, the metric scores for high performing metrics, they does not fluctuate a lot. Again, on the horizontal axis, we have different pooling methodologies. In each column, we have different pooling methodologies. And the plots are more or less the same for all the pooling methodologies for high performing metrics. But for the lower two low performing metrics, we see some differences in each plot. So this means that, again, they might be explained by their low performance. And this result, again, can be observed on the correlation results we acquire. With different pooling methods, we don't see a lot of fluctuation in metric performance. So this means that we don't need to actually go through very complex pooling strategies. We can simply use arithmetic pooling and with as low as we can go on the frame rate, basically. So this kind of concludes the talk here. And one final thing is the combine effect. We didn't see any pattern that emerged from this experiment, this study. So on each pooling method is split into column of 8 here. And at each column, we have 1 FPS, 3 FPS, 5 FPS, and increasing from left to right. So this, and each row is one metric in this heat map. So to see if there is a pattern of metric performances on this heat map, we plotted all together. But as I said, there is, as also you can see, there is not much pattern here that can be observed. And this kind of concludes the talk here. And to summarize, yes, we don't need to go up to 30 frames per second or even higher if that is the case. But of course, to be able to say this generally for other type of volumetric video content, it might be better to have more studies, because this is limited to human content that is only available in VScience BBDB2 dataset. And the distortions are compression distortions that are very uniformly visible on the content. So if I think the distortion types hold this true, we can safely assume that the same results will hold true for those content. Yeah. Thank you. Yes.
I have one question. So you said that you use compression and you use, I think, PCC and GPCC in order to compress contents. Is it correct?
Yeah. So this is actually the VScience BBDB2 dataset. As you know, it's from Trinity VScience. So we didn't do that, but they did it. Yeah.
Yeah, no, I mean, I wanted to see actually this.
Yeah.
You had both all intra and random access.
Exactly.
So in BPCC random access, since it wasn't intra, how big was the group of pictures?
Hard to tell. Right now, it's hard to tell. I can show you after at the coffee break. I have the data set in the hard disk, but yeah.
I would be interested because I mean, like, depending on the group of picture, like it could change. Like, you know, like the subsampling rate.
Yeah.
A moving window, maybe the results might change, or maybe not.
Yeah. We can check. We can check.
I am not doing the poster. Yeah, I'm not even answering that.
Okay.
I think he said that he put it out in the chat.
But there is nothing in the chat.
Can you answer it just saying? Maybe not in this chat.
Is there other chat? Sorry, should I do anything? Yeah.
On page 18.
Yeah.
I want to know that there are numbers that the decimal numbers 4, but I'm thinking that 0.9081 and
Yeah.
0.9077, they are really close together. How do you make the difference between these two numbers? And what is
Yeah, normally what you want to do is do a statistical analysis to check the difference is statistically significant or not. But in this case, we didn't. Not really but we just wanted to explore basically the point, temporal pooling methods effect on the performances. So to see the statistical significance, you need to apply the appropriate tests. But in this case, I can safely say that there is no significant difference between 9088 and 9081. It's safe to assume, I think. Okay.
Did you try other 20-point metrics that are a bit more complex, like DCQM or Fuentes-Seselian or stuff like that?
No, I think at the time of the study, with we also elected these metrics based on the availability, etc. And sometimes it's also the complexity because the amount of calculations we had to complete. Some metrics ran for 2 weeks because we have like 56 combination, and each stimuli has 300 frames, and we have I think 140 stimuli. So much calculation, so sometimes it's not worth it if the one frame takes like 1 minute. Maybe not worth it to follow through.
Thank you for the presentation. What's about more complex quantums? I mean, different objects or different quantum views.
Yes, so unfortunately for volumetric video quality data sets, as far as I know, this is the only data set. So it's hard to say it will be the same result because there is no way to test it, at least right now. But I think complexity of the point cloud might be an issue at certain points, but probably it will have the same output as this.
We have to integrate selection.
Yeah, that actually we are currently trying. We are comparing principal component analysis, also a work from my previous colleague Mona Bit, as you already met her, for selecting an appropriate view on the point around the point cloud to basically come up with the best possible representation, and then just calculate the quality of that frame, and then maybe additional 2-3 frames, but just a few frames so that we can actually don't need to go through everything. Do we have any question?
Any other questions? Otherwise, I think we go to the
Next
next
yes.
presentation.
Yes, continue. Yeah, tell it, man. Huh. Wait. Steve, sorry.
Is it not on full screen?
There is a delay, right?
On my laptop is a full screen, like, but here is like.
Yeah, there is a delay. That's fine. Probably the
It's a
online
delay.
participants can
It's the next
see.
presentation.
It's not moving.
It's like other way around, It's already.
How are you?
This time is the next presentation.
What is happening? I don't know.
You are connected to Zoom?
Yes.
Press again there.
Yes, sir.
No, so it seems that the
Maybe
presentation.
reconnect again.
I know it's moving.
Yeah, but
Yeah, but I think because the display, we should see that the display is.
this one is fine.
Does it move without the
Can you
presentation?
do it like this?
Yeah, I
Or
mean,
you
It's
prefer
okay.
to-
I don't know what.
I think it should be some settings of the presentation mode, but if you can do this, I mean, if you can do it like this, we can go faster.
Okay.
Yeah.
Okay. Okay, should I start?
yes, please.
Thank you. Thank you. Hello everyone, my name is Vakas Lai, and today I'm here to present my one work which I published in last year in MMSP. So the title of my presentation is like a machine learning framework to predict TMO preference based on image and visual attention features. This work I did it with my two other authors like Patrick Lecole and Tano Vijay. So the outline of the presentation is like visual attention and its application, using different application, HDR and importance of TMO, visual attention and tune mapping operator, then contributions, and then we have used different feature set to input in our framework. Then the diagram for the framework, overall diagram for the framework, the data set, finally the results and conclusion feature plan. So normally, usually, natural scenes contain a large amount of information that cannot be processed simultaneously. And visual attention is a part of human visual systems help to regulate the resources to extract the useful and meaningful information. And it's already been used in different kind of applications, especially in image video compressions and rendering technologies. HDR images actually are more realistic and more natural because it's contain a large dynamic range of the visual contents. But the problem with them that you need a specific hardware to display them, which are expensive and still not reachable of the end user. So tune mapping operators are used to convert the high dynamic range content to standard dynamic range content. And to display them on a conventional traditional display. Some regions in an image attract more human attentions that call as the silent regions. One of our old colleague members in lab, he studied about the impact of TMO or tool mapping operator on visual attention, and he studied and he found that he found that the visual attention is modified by the tune mapping operator. And then he compared the silency maps between HDR and TMO. And here in these figures, in these two figures, you can the red box is not clear here, but the red box is highlighted. The some regions are silent in one TMO compared to the other TMO. So in this work, we propose a machine learning based framework to predict the preference of mapping images instead of a value quality scores, because we use a pair comparison methodology because it's more reliable and reduce the subject uncertainty, and also investigate different visual attention features for the prediction of preference level. We use different kind of features. First, we divided into two categories, like image-based features and visual attention-based feature. In image-based features, we use same from our lab. One our old guy, old lab members. He did some study, like he found out 5 best feature out of 60 for preference learning for preference learning of tune map images. So we use the same 5 features for image-based. For visual attention phase, we further divided into two categories. One is visual attention similarity based features, and second is visual attention complexity based features. In visual attention similarity based feature, we have 4 different features, like to find the similarity between the silency map, some similarity between silency maps. We use 4 different features like correlation, KLD, NSS, and to find the similarity between the gaze points or fixation point, we use a fixation cluster based HMM hidden Markov model. And for attention complexity, we use 2 different methods, entropy based and inter-observer congruency based. So here is the complete diagram for the framework. Different features calculated by different kind of inputs, like structure similarity and feature similarities computed between HDR and TMO content. Similarly, feature naturalness is computed by only TMO content. For visual complexity based features computed by excellency maps of the TMO, and visual attention similarity based features computed between excellency maps of the TMO or a gaze data of the TMO. And in this framework, we predict the preference labels of preference labels. So we use but not test to convert a number of votes into labels and we employed support vector machines to map the input feature into output. We evaluate our dataset on we evaluate our method on 2 different datasets, and we extended this dataset to gather eye tracking data in a lab. So in XTMO dataset, we have 20 source images, 4 HRC images, so we have total 80 TMO images. And 40 participants are observer are participate in voting experiment, and 9 to 19 in eye tracking experiment. And similarly for peer TMO, we have a 90 TMO images and 20 observers in voting experiment, and 27 to 28 in eye tracking experiment. And we have 92 significant pairs after out of 120 for XTMO dataset, and 204 pair TMO significant pair out of 360 for pair TMO dataset. Here is the performance table for different features of, with the framework. So for individual image-based features, when we input our individual image-based features, the performance varies from 56% to 68% for XTMO dataset, and the accuracy for peer TMO dataset is range from 63% to 67%. But when we combine image-based features and input to the framework, the performance is increased, like 73% for peer TMO data for XTMO dataset and 68% for peer TMO dataset. And with integration of image-based visual attention-based feature, the performance is improved, and the best results we get with interobserver congruency, and with 81% for XTMO dataset and 78% for pure TMO dataset. Here is actually the here is the plot for performance of the framework with board distribution. You can with the performance of the framework is more accurate when the observers the more observers agree that TMO1 TMO-I is greater is better than TMO-J. And the second thing is that when we integrate the visual attention features, the number of misclassification in each bin is decreased. We test our performance. We compare our performance with another method, is FFTMI. He used the same feature like we did it, but in a linear equation to get a quality score. So the performance of this method is 58% accuracy with on XTMO dataset and 58% on PRTMO dataset. When the same features input with our framework, we get 73% accuracy on XTMO dataset and 68% on PRTMO dataset due to introduce of non-linearity of support vector machine. And with integration of visual attention feature, the performance further increases, like 81% for XTMO dataset and 78% for PRTMO dataset. So conclusion and future. So we propose a machine learning based framework for preference prediction between pair of tool map images, and also we investigate the visual attention features for this study. These results demonstrate that the integration of inter-observer congruency with image-based feature lead up good results. And the one possibility to further extend it, like to replace right now we compute IOC with gaze data. The one possibility is to replace this one with some computational model to predict the IOC score directly from the image. Thank you very much. Any question?
Thank you. Questions?
One question is that you use a software vector machine.
Yes, but
Is there any opportunity to compare with other techniques in machine learning, or you want to do in the future?
Yeah, it can be a possibility, but we have a boundary classification, so mostly sport vector machines go to better results, so that's why I use it. So it can be a possibility to check it on other classifier.
There is a question on the back.
How can we compare more than 2 images?
More than 2 images?
Yeah.
So the question is, how can we compare more than 2 images?
Yeah, I understand.
Like, how we extend the work?
For machine learning stuff, we need some labeling data. First, we need some data set that we have different ranking, and we have some techniques to rank some multiple to rank more than 2. So, but I think with SVM it's not possible. But still, like in machine learning, we have. I remember when I studied it, we still have some ranking machine learning frameworks. Like mostly when we search them, some Google search in some Google, we get some multiple results. So I think that techniques can be helped, but I need to explore more in that direction. I think rank SVM something. Some methods are available, but I don't know. Any other question?
Okay, let's see any other questions. So thank you so much.
Thank you.
Thank you for good presentation. I think Jesus, that concludes the.
Yeah, just Irene wants to show one slide very fast and we will close our.
Okay, yeah.
So one slide. Advertisement.
Ah. No commercial advertising. No.
Should
Should I share through Zoom? Or,
Yes, please.
This should work. I hope that you can see it.
Yes.
Yeah, so it's really advertisement, and it's because IMG is an immersive media. And me and Hadi here are co-organizing an international workshop in ACM Multimedia on interactive extended reality. One of the topic of interest is quality of experience management for interactive immersive media application, which I think would be interested for people here. The deadline is June 20, so there's still 1 month and some days in order to prepare a submission, 6 to 8 pages plus 2 additional pages for references. You can follow the QR code or like click on the link basically in order to see the web page. We will update it soon with also with the TPC and everything. And yeah, we hope to receive your submissions. And that's it.
Can you wait for a second?
Yes. Does it work, the QR code? I hope it does.
Let's see.
Didn't test it. I trusted Google.
It does. Yes.
Amazing. The power of technology.
It's dinosaur.
What?
Dinosaur.
Yeah. That's Google just puts the, which I don't know why. That's the logo for when web pages don't load. So I don't know why they put that in the QR code. It's a bit creepy in that sense, but yeah. Yeah. Okay.
Okay. Thank you.
Thank you. I think there are no questions for this, so I can go.
So let's move on to the norm session. So who is going to share the norm session? Is there anyone online that is going to share the norm session? So maybe we should postpone norm until someone can share it, so we can go on with the QAH.
Makes sense.
Mainly US contribution, maybe. I didn't see the list, but Dr. So Enrique.
Are you ready? Yeah, I can share the storage.
Okay.
Should I?
Yeah, sure. Please.
Thank you.
Let's go to Oslo because I have to meeting between 3 and 4.
Okay, so we are going to start the quality assessment for health. Yeah, for health applications. So we are supposed to have 4 presentations for this part, but I actually did mine on Monday during the project overview. So maybe I don't need to do it again. I think
Which
it was
is that one?
123, I think. Yeah.
So we delete that one.
Yeah.
Here.
So then
Was
we
that
have.
was not listed here.
Yeah.
So I put it back.
It was the summary of what we did in the project.
Okay, so I moved.
And so then we have a presentation from Marwan. Okay, so Miriam, are you ready? So Miriam, if so we will start with presentation 122, Miriam Outas. Do you want to sit, Miriam? Tiens, vas-y, tu peux te mettre là. Non, mais assieds-toi. C'est bon? Ouais, mais comme ça, prends le micro pour qu'on t'entende mieux. Ah. Ouais. Je partage. Non. Non, il m'a déconnecté.
Par contre, j'ai pas tes notes.
Non, mais c'est pas grave.
Je peux les avoir à côté.
Il va. Oui, mais vous n'avez peut-être pas besoin. Ok. Ok. Je vais passer chez toi. Peut-être. Non, c'est pas la peine.
C'est pas la bonne.
C'est pas la peine.
C'est pas la bonne. It's not the good one, sorry.
Sorry. Zoom disconnected me.
Ah, je l'ai pas vu.
Ah si, elle est sur le share, sur
Ouais.
Google.
Ouais.
Sinon, c'est sans que. Ok.
Et comment tu
Je sais pas. Partager. Diapo. Diaporama. Ok. We'll present you a work that have been done by Huda Jebari during her internship. So in our lab, it's entitled the Image Quality Assessment through the Detection Task of COVID-19 Pneumonia. Here is the outline, so I will pass maybe. Medical, as you know, medical images play important role in the diagnostic of lung infection, and more specifically in pneumonia, which is an inflammation of the lung tissue. I think that we all remember COVID-19 emergence. So computed tomography has helped within the diagnostic of this disease and the severity of patient's infection. So, and the quality depends highly on the acquisition and reconstruction of the images. So now low dose standard is the low dose is the standard for taking the images, as it reduces the X-ray risk. So the last recommendation of World Health Organization is to minimize the dose radiation that can affect human health, but with maintaining of the diagnostic image quality. So the question is, can we improve the diagnostic image quality by reducing the noise by reducing noise in CT? So I don't know, maybe all of you know the task-based approach. So it was presented in that meeting of VICWEG. So as you know, the image quality can be assessed in a context of a specific tasks. So for example, detection or localization in our case of the pneumonia of the lesion. So the idea is that medical experts, which are human observer, performs a diagnostic tasks in different medical imaging systems. Let's say that. For our case, it will be maybe denoising, which is which will be interesting. So after we have a computation of quantitative value, which can characterizes the radiologist's task performance for example, a medical imaging system, which we call the figure of merit. This comparison, the comparison of figure of merits, will indicate the better system. Okay. Now, can we have a model observer, which are models that can perform the same task as a human observer? This model observer needs some information about the images
like lesion types, background, lesion location, maybe lesion width, type of noise, lesion amplitude, and so on. So now research studies are mostly used simulated images. So in our case, we tried to use and study on real images. So let's show the result. Just I want to add something that we can find in the state of the art. Lee and all tried to apply AI denoising on simulated images. And the conclusion was a loss of task relevant information. So for us, we tried another methodology. So we used a classifier, so which is based on supervised learning method for detection tasks. This will play the role of model observer by doing a binary classification. So better detection will mean better system. For the methodology, the first step was to choose a database which result of low-dose CT scan of COVID infected and non-infected images in order to do the classification. After, we select two methods of denoising, which are classical methods, not AI-based. After, we look for a classifier based on supervised learning method. And the last step was the evaluation of the detection step performed by the classifier on the original database and with denoising images. So here you have a review of COVID-19 database. So non-exhaustive with some interesting maybe information. As if we have COVID, non-COVID, another pneumopathia, here a CAP, and the application, the CT volume, and so on. So we choose some elements to obtain our COVID database that we will use. Maybe it's interesting to contain COVID, non-COVID, and other pneumopathia. It should contain a wide variety of lab blood data, and it's more interesting to have a single equipment in our construction in order to have reliable results. So on this way, according to the criteria, the chosen database was the COVID CTMD database. After that, the Huda searched about a classifier. So she selected a number of classifier. Also here, some criteria was chosen. So maybe it was interesting for us to choose a classifier that can classify 3D CT volume in order to have a patient level classification instead of slice level detection. So it should have a good accuracy and precision and avoid data augmentation because of the real medical images. So according to this criteria, the COVID fact was the one that we choose to classify the images. So here you have the an architecture of the COVID fact. The COVID fact has two stages. One, to train the annotated subset of data to detect slice demonstrating infection. And the second stage that we haven't time to test because it has to classify the infected slice into COVID and non-COVID, another pneumopathia. For the denoising methods, as I told at the beginning, we choose classical denoising method and not AI-based methods. So two well-known denoising methods on CT scan, anisotropic diffusion filter and adaptive total variation filter. Here are some results. So the baseline method, the baseline model indicates the original images without denoising, so low dose images, and the two others are the chosen denoising methods. So the result is that the specificity and the precision was better with adaptive to the total variation methods, but okay, it's good, but it's not enough for us finally, because the denoising method, okay, enables a slight better classification, but only of non-affected slice. So this was not okay for us, even if ATV model reached best specificity. So baseline model classified better the infected slice. So in our case, the problem is some infected slice looked like non-affected slice because this denoising method reduced the visibility of some structural detail and low contrast texture. So to conclude quickly, we tried to study the impact of denoising method in COVID-19 classification tasks, but on real images. The only first step of COVID fact was successfully performed, and the result was interesting, but still need to be improved, maybe by fine-tuning or achieving another method of denoising, but the internship was finished before. So maybe try to determine and model the noise or choose different methods. But this was an interesting experiment because it was on real images, and they give us how we say, idea for a new PhD thesis. So by Lumi, that you know now. She was really present in the VQuake. So maybe we are going backwards and take a reverse problem. And we will simulate radiation dose and try to define a minimum dose that can guarantee the diagnostic quality. I think that in the next VQuake meeting, Lumi will present some interesting results. That's it. Thank you for your attention.
Thank you, Mariam. We already have some questions in the room. Lucian, yes.
Thank you. It's very interesting topic and nice presentation. I'm just wondering because using denoising for artificial intelligence algorithm can be counterproductive because they are trained on noisy data. Like the typical thing you do is to add noise so you are not getting to overfit. So that is why adding slight noise shouldn't change the performance at all, but removing noise is going into other direction in the image distortion. And I guess that this is like to some extent
about future work you are talking about.
Why the results are like that.
Yes.
I think that maybe for humans it would be easier to detect or something. Yeah, we don't know, of course. And I fully understand that tests on humans are super difficult with medical doctors, and especially with that you cannot show the same image to the same person many times. It doesn't make any sense. So it's very nice idea, very nice approach to use AI instead. But the only thing is that with the AI, the problem is that how AI is seeing noise is different than humans.
Yeah.
So at the end, yeah. And I have, it's just a comment, but I have no idea how to, deal with it.
Yeah, and in that period, we couldn't have help of medical expert because of COVID.
Yeah, of course.
But hopefully now we are discussing with the other doctors, and for this reason we are waiting for better results. But maybe denoising, yeah, maybe all denoising methods, even based on AI or a traditional one, are not maybe not interesting for a medical expert.
Yeah. Yeah, what would be my advice is that it's a nice idea to use AI and to have some preliminary results, and then try to get even better results with the students who will have much more time and they are not trained well, so they are probably something between AI and experts.
Or maybe you can just compare, these two groups. I mean,
Yeah.
the AI and students, and then if this is like more or less same, then you could use AI.
Or seeing some trends, and then only at the end, take the time for the medical doctors.
Yes, or have also the real model of noise, because finally it's difficult to have the model of noise. We tried, we have now some phantom, but it's difficult to obtain two different doses of radiation in one patient. This is not ethical at all, even if we found some papers that deals with that, but we didn't understand how they could obtain. So we are on the subject.
Oh. Okay, yeah, but then it's super tough.
Yes.
We don't have a model of noise.
It's difficult to obtain. I don't know. Lumi maybe can confirm, but it's difficult to obtain a model of noise.
Totally makes sense. Actually.
Yeah, we are trying to do so with the phantom images, but phantom images are completely homogeneous. So for us, it's difficult. For vessels, bones, the noise will be not the same. The dose radiation will
probably you would need radiation of some animals or something like that, but even that would be super expensive, and
we have to take the animals to the hospital. So I'm not sure that they will agree.
I'm pretty sure that they have radiation devices in the pets, things like that.
We will try to.
But because then probably ethical commission will be more into, especially that you have a very good reason to do so, because you want to have a lower dose of radiation and you need. So, but this could be done already, so this could be searched for
I think
like that. But anyway, even if you wanted to do it, then there such a research project would be very tough and long time. Because any research project, I think you always have to mark if you involve animals, and I guess you involve, and then become a nightmare.
Or just the simple idea is to buy a real good phantom. Now there is a phantom proposed by, I don't know, NIST or something like this, but we have some phantom. I think that maybe it's expensive, but in the hospital they don't have this sort of phantom.
Some people don't know what is phantom.
Sorry.
Artificial human. You can make a test of different medical things. Well, I'm not sure if they have similar radiation properties.
No, it's simple to realize a phantom with the gelatin for ultrasound images. if you want, I put a recipe, I don't know, in my PhD thesis. But for CT scan, we have to buy it, I think. But for example, to try ultrasound, you have to try this. It's really interesting.
Okay, thank you, Lucien, for the question.
Thank you, and for the suggestion.
Yeah, I don't know if we have more questions in the room or in the chat. Shell, can you see anything in the chat? I can't I think
No.
No. Thank you, Mariam.
Thank you.
Are you ready now, Marwan?
Yeah.
You can come here if you want to come to you. So now we will have a presentation from Marwan. Presentation 125.
So hello everybody, hello again. Today's presentation, I would like to present for you our recent also submitted paper at this IC. It is related or linked to what I presented it yesterday, not from the perspective of the domain of application, because this one is about medical imaging, but is related to it from the general goal where it addresses the problem how we could push the representation learning only from limited amount of data for quality assessment in general throughout unsupervised domain adaptation. So a brief agenda, problem setting, proposed framework, experimental result, and finally the conclusion. As motivation, quickly, medical imaging consists of set of process or technique to create visual representation of anterior parts of the body for clinical purpose, such as those kind of data could be such as X-ray, MRI, or ultrasound images. The proposed question why medical imaging is important. Medical imaging is absolutely necessary when tracking the progress of ongoing illness. Ultrasound images, for instance, allow the physician to monitor the effectiveness of the treatment and adjust protocol as necessary. When the detailed information, where the detailed information generated from medical images provide with a better and a more comprehensive understanding of the observed data. So high quality of medical images would improve the decision making. That can, of course, reduce unnecessary medical procedure like interventions. So it's of critical importance and of critical interest to develop a framework that could be adequately evaluate the perceptual quality of medical imaging, and that give to doctors enough information to take the good decisions. To do that, our goal is to develop an end-to-end efficient objective framework that could be extended to quantify the quality of medical imaging on limited amount of labeled data. Why efficient? As I said yesterday, because always we want to satisfy the requirement of deployment purposes on edge devices and on limited data because we have no choice. There is no that much of labeled data for medical images. It is not secret anymore that training deep convolutional neural network has become the rule of thumb for computer vision for computer vision applications or image recognitions, and thus because its great ability in extracting hierarchical representation throughout multiple layers with enlarged receptive field to detect some kind of complex structures like faces or cars and so on. This kind of architecture would work pretty well for tasks like classifications or segmentation, and that's why, because it satisfies its inductive bias to detect the location of object where it is in the scene. I mean by inductive bias here, the set of assumptions that is needed for classification and segmentations. Like for classification, we need our inductive bias should satisfy the requirement of shift invariance. What I mean by shift invariance, we want to our network to do not produce different variant of output only by applying a linear transformations to the objects in the input images. Wherever the transformation apply to the input X, always we should have the same probability or the modeled probability. And for the case of segmentations, which is another downstream task, we want wherever the transformation applied to X should be applied also to the result of f of X. As I said, convolution neural network or deep convolution method satisfy the requirement for this kind of application related to image recognition. But what about image quality assessment or our perceptual downstream task? Do we really not need to find out the location of object? Are we really interested about the symmetry invariance here? In much detail, so we need to reduce the scope of hypothesis space to learn a better mapping functions for the quality, our mean opinion score from the input images, or to define better our set of assumptions about our domain of learning that we are trying to learn about. Okay. To do so, we have proposed a shallow method that capture inspired from that inequality assessment. We are interested more and more about local features than global one. As I said, the location of object in a scene or those related things to recognitions. We are interested about the effects that are applied on local ones. So what we proposed here, we proposed a shallow network that itself slides over the input image that contains shallow convolution and itself also slides over the input image. So-called SAQM, slide and window self-attention quality metric. The architecture of our network is illustrated in what follow. From each patch we applied three transformation, key, query, and value. We measure the similarity between the key and the query, and we produce a heat map of probability that would be later used to enhance the value vectors. Then later we pass this value vector to a regressor in order to estimate the final quality as probability distribution throughout a sigmoid functions. Training this kind of architecture, which is so shallow, it's so shallow because we wanted to precise directly the effects that are applied on the local features. So we are trying to avoid overparameterization and add a limit to our neural networks. Training on limited amount of data would not be also the case because we will not have an enough of feature space and white space to achieve the better mapping. Where in supervised learning from feature space X and a space of label Y, we are trying to model the posterior conditional events to produce our mapping functions on large amount of data. As I said, it's not impossible for our case. So as a solution, we propose to use unsupervised domain adaptations to give an intuition about what is domain adaptation exactly. In supervised learning, always we hope that the distribution that our data in training set should be the same on the test set in order to be our function always be able to achieve the correct mapping from the feature space to the label space. But what happens if some effect would be applied on our feature spaces? Like we see here the case of driving cars. some effect would totally change the decision of our model. How to always make our model restricted to quantify the right informations from the input state. As we see here, this is in plot A is a non-adapted data where we have two distributions, source domain and the target domain. Could be explained here as the case of medical images. The blue is from natural scene images and the red is from medical images. Here, we have two separate distributions. So our data could be explained as distribution of S plus a distribution of source plus distribution of target. So what we want exactly is we want to make our model to extract the same information wherever the distribution of the data and focus only on the informative feature that could guide a better prediction or a better modeling of the to the posterior conditional evidence here, I mean. So as trivial solution, we should find a way in order to remove the noises that is related to each domain, to remove the noise of source domain and remove the noise of the target domain. In this way, we will force our model to align all the features that are coming from different distributions. To do so, we use unsupervised domain adaptation by backpropagation technique, where the idea is only to add a domain classifier beside our decoder. The goal from the domain classifier is to classify the source of data, where it belongs to medical data or natural scene data, and add a gradient reversal layer after exactly the encoder for the sake of applying the alignment or the feature alignment. Why gradient reversal layer? The gradient reversal layer would inverse the sign of our gradient during the backpropagations. So it would maximize the loss. As we know, minimizing the loss would maximize the separation between the classes or between data distribution in order to apply better classifications. And maximize the loss would do exactly the same thing on this part, would would minimize the distance between the distribution of different classes. And this way, we will satisfy our goal, which is to apply adaptations to make the two distributions belong to the same thing or produce the same thing. Okay. So in order to validate the accuracy of our method, we have tested it on TID 13, which is a natural scene dataset, and MD 72, which is a medical imaging dataset. MD 72 is a dataset composed of 72 liver ultrasonic images with the corresponding mean opinion score. More precisely, 60 denoised images were derived from 12 pristine images through 5 denoising algorithms. And in order to try to keep the task as much as possible, we used also a dataset on natural scene images which contain only a denoising, which contain only denoised images. We have here 4 settings. The setting 1, we use fully supervised approach without domain adaptations by training the model on only the medical imaging dataset, which is a limited amount of data. As we see, the results are so poor. And for setting 2, we train our model in fully supervised approach without domain adaptation, just only on natural scene data. However, the model is able always to make a better, even a better predictions on even the medical data, which has not been shown to him before. And in setting 3, we use unsupervised domain adaptations by using an images from TID 13 as source domain and MD 72 as target domain. And in setting 4, we are using a semi-supervised domain adaptation by using TID as source domain and MD 72 as target domain. So we add also some part of medical data, and it can be seen that there is a clear leap in performance for setting 4. In table 3, we are showing the result of our method regarding the rest of state-of-the-art one. So in this paper, we proposed a novel method for quality assessment of medical images. In particular, we look to address the task of predicting the satisfied ultrasound images quality for applying an accurate diagnosis from small amount of annotated data. To this end, we employ a shallow convolutional neural network as a self-attention module in order to model efficiently complex representation from local features that affect the visual perception. We also used unsupervised and semi-supervised domain adaptation learning to reduce the shift between the data domains distributions. That's all. And this is question.
Thank you, Marwan.
I have tried to be so quick as you asked me and reduce a lot of things unnecessary details.
Any questions in the room or on Zoom?
Yeah.
Yeah,
I would like if you could come back on the explanation of the training procedure. Yeah, because
I need this one.
Yeah, that like when how you no. Yeah,
This one?
Yeah.
This is our architecture, not the training procedure.
Yeah, but you have also how the gradient is propagating. But
yeah.
So what you mean is, so you have two classes, two tasks.
We have one task. This is domain adaptation is a subtask of transfer learning. In transfer learning, when by applying taking the model which is trained, by the way, on ImageNet and transfer it on small data, another small data set for another task, and doing fine tuning just by training the head of this model.
So
this case we have no. I'm explaining in general. This case is where we have two different tasks. Two different tasks, but the same domain of data. So the model could extract the same thing. So the encoder, which is the first part, could extract the same feature or the same informations, wherever the domain of data. Our problem is just with the decoder to adapt it to the task. But here in medical images, we want also to train our encoder. We want to train our encoder to extract the same information and focus only on the features which are related to the quality task. As I said yesterday, if you remember, the distribution of space X could be represented, feature space X could be represented of quality. This is our adaptive base, which we are defined it. Could be represented as distribution of features that are related to quality and other distributions that not related to quality, related to another downstream task. So in this way, we are pushing our model to learn just on these distributions of feature. How is it that exactly? We add in another head, which is for classifying the domain. Each time we give to our method model an image which is belong to the domain of medical data and an image which is belong to the natural scene images. And the rule of this one is just to predict the quality score, and the rule of this one is just to predict where this image belong, to which domain belong. After that, for this one, we minimize the loss. So we have a normal back propagation here. For this one, we minimize the loss. We have a normal back propagation. But when we come here, we want the both features that either from the first domain or the second domain to be exactly the same. How to do that exactly? We are adding a gradient reversal layer. The goal from the gradient reversal layer is just to reverse the sign of the gradient during the back propagation. Reversing the sign of the gradient would maximize the loss. But as we know, minimize the loss is in casual model, minimize the loss mean maximize the separation between the distribution of classes. To minimize the loss, maximize the separation between distributions, so we could be able to make a clear mapping. The input is belong to this class or to the second class, the case of classification. But maximize the loss would do the inverse, would bring the two distributions to be exactly the same. This is the general idea from unsupervised domain adaptation.
I think that the easiest to understand example is how it was invented, because the guy who invented it, they did it for, I think, some crime detection algorithm or something like that. On one hand side, on the other hand side, you want this network not to be biased by by
the feature related to the domain or the effect added to the domains.
Yeah,
like the case here.
Racist, yeah.
Like the case here of self-driving cars, our images, which we could find it on the training data, are normal, but in the real case scenario, we find a lot of effects. So we want to have the same accuracy of predictions or model our conditional probability on the same way. Model our conditional evidence in the same way, wherever the input data or wherever the noise added to the input data. And the goal from self-attention is just to have a shallow model that captures the long range of dependencies between local features to interpolate a better quality.
Okay, thank you. Do we have any other questions in the room or on Zoom? If not, we can move to the last presentation for this session, which is Yuhao Sun, who is remote. So can you stop maybe sharing your screen?
Thank you.
Yeah, so Yuhao, you can start sharing your screen.
Yes, thank you, Lucy. Can you see my screen now?
Nope, not yet, but it's, yeah, now it's okay.
Okay. Okay, good afternoon, everyone. I'm Yuhao from currently a PhD student in the University of Edinburgh. And yeah, good afternoon from UK, and maybe some people remoting to see this meeting. Good morning or good evening to everyone, all of you here. Be sure inclusive. The title of my presentation today is Visual Distortion of Medical Images, Non-Reference Image Quality Assessments Evaluated in CT Scans. So basically, currently there are still some circumstances that visual distortion happens in clinical area, especially in medical imaging. And in our research, we'd like to find out some impact of visual distortion on medical images. So we determine if current non-reference objective IQA metrics function as well as humanized as we consider human being will be the ultimate users in the image quality assessment. And yeah, the results have been published in the IANG International Journal of Computer Science for the recent volume. So basically we focus on a distortion in computer tomography scans, and we focus on the blurry, contrast distorted, noise distorted, and also in the research we compare the results between the subjective and objective IQA. Basically, we trying to find out the results in objective IQA by confirming the results from clinicians or radiologists in the subjective IQA. And we found out that the results between two IQA was similar at 80%. And also in the end, one of the metrics, which called perception-based image quality evaluator, performed very well in recognizing the distortion situation in CT scans. And yeah, this is a nutshell in our research. And our research has been divided in four main parts. The first one is data construction. Second one is IQA, which composed of two parts, subjective IQA and objective IQA. And after that, we will give a comparative analysis between two IQA, which generated previously. As a computer scientist perspective, we have been conducted a pre-assessment questionnaire before the data construction and the image quality assessment. This is because we'd like to understand well and fully the basic situation of the visual distortion in medical images in hospital and healthcare institutions. And yeah, so that's why we have done a pre-assessment questionnaire. You know, our computer scientists, researchers can fully understand our research is useful to from a clinical perspective. And for the data construction part, we use the high quality and also trying to process these high quality CT scans to other type of distorted photos. And yep, that's a method of our research. So the first one will be the pre-assessment questionnaire. Basically, in this step, we'd like to analyze the topic from the perspective of healthcare staff and trying to access some basic data for the subjective accuracy for later on. And in this questionnaire, we have designed 11 questions, and which including the 4 demographic questions, 7 medical imaging and distortion related questions. We distributed our questionnaire online and to the doctors, clinicians, and the radiologists in many hospitals, mainly in a city of Shenzhen, China. And we eventually collected 51 valid results response, which including 43 clinicians and 8 radiologists. So here I'd like to mention 2 important questions, which the first one is, have you ever encountered the problem of medical imaging distortion? And we surprisingly found out that 92% of respondents claim yes, that they have been encountered the problem of medical imaging distortion. So which we surprised a little bit, as this questionnaire has been conducted in 2020, and we thought the current technology is improved and advanced quite enough. So, but there's still some phenomena, that there's some circumstances that they found out that the medical imagings have been distorted in some sort of situation. And for the question is, what kind of types of distortion have you ever encountered? We have been set it for 4 choices, which is contrast distorted, blurry distorted, obscure distorted, and compression distorted. So as you can see here, the 76.5% respondents choose that blurry is frequent in their working time. And then it's contrast, which takes 43%, and obscure distorted takes 31%. So from this pre-assessment questionnaire, we also have a general idea on the frequency on the distortion types, which is blurry, more than contrast distorted, more than obscure distorted. So based on the results, would have generated.
Yohao, sorry, can you come back to the slide before, please? We have a question here.
Yeah.
So just a short question, from where the compression comes from, because like a typical standard in medicine is not to compress images at all.
Sorry, I beg your pardon?
From where does the compression come from? Because there are standards in medical imaging where compression is not supposed to be used.
Yeah, this is a question that how the doctors can receive the distortion. So we didn't really like involve how the compression come from actually.
And so I have a question as well for this slide, so maybe I can ask it now. How did you do to ask the clinicians and radiologists which type of distortion they see? I mean, do they know what is contrast, blurry, obscured, or compression distortions? Did you show them examples before? Or?
Yeah, we showed them a set of example of what is a blurry, contrast, distorted, obscure, distorted. So I will mention this later on actually.
Thank you. Okay, we have another question in the room.
Yeah, in normal for traditional images for applications, the blurry distortion might be, or the contrast distortion might be like very high contrast can be seen as a distortion because it might affect you badly, but maybe increasing the contrast in medical imaging is not necessarily a distortion all the time. Maybe it's actually a beneficial thing.
Yeah.
How do they define the distortion in this?
So the question is, so for natural images, contrast can be a problem, but maybe for medical images, contrast can be useful sometimes to better see the lesions or the organs. And so how do you compare the useful contrast and the distortion contrasts?
Yeah, this is one of our results in the later on.
Okay. So maybe we should go on with the presentation and the question later. It's okay. So
thank you for all of your questions. Yeah, thank you. Okay, so So the first step, we have been, based on our results in the pre-assessment questionnaire, we would like to construct a data set. And for this part, we wanted to have a first-hand CT scans, but for many reasons, mostly ethical profile, we decided to choose the second-hand dataset from National Institute of Health dataset. So here we found out that they are mostly distortion-free, high quality, and some of CT scans are up to date. And most importantly, they have some annotations which shows that the lesions, the size of lesion, and the location of the lesion in CT scans. And we originally chose 20 original images. And for each age group, we chose 4, which including 2 for male and 2 for female. So from 21 to 30 years old until 61 to 70 years old, we've got 20 original images, which has been considered as high quality. We use MATLAB to process these original images here to the blurry, contrast, and noisy distorted. Actually here, the ratio 2017-9:4 is roughly equals to the pre-assessment questionnaire ratio. The question we asked, what type of distortion have been encountered in hospital or healthcare institute. So that's why we have been said that question before. And here is a example set of the data set. So as you can see here is the original image, and we process to the blurry, distorted, and the contrast distorted, and also noise distorted. So we go for the first IQA, which is subjective IQA. We'd like to determine the medical imaging quality with the views from clinicians and the radiologists. As I said before, we've been considering that the human eyes will be the ultimate users in image quality assessment. We got 3 observers in subjective IQA, and 2 of them are clinicians and 1 of the radiologists. So we choose the first and the third respondents as our main usage in the subjective IQA. In this IQA, we chose we have 50 medical images, including the original one and distorted one. And for each image, we ask 4 questions. Basically, we ask them where's the lesion, and do you think what is the quality of your thing? To what extent you think this is a good quality image from your perspective? And it's also conducted in a hospital of Shenzhen, China, one of city in China. And we found out that subjective IQA is expensive and time consuming. As you can see here, even though that the clinicians with more than 13 years experience, they finish this assessment around 31 minutes. And also radiologists is because medical imaging is their expertise, so they may finish a little bit shorter than the clinicians. And so that is an overall overview of subject IQA. We have done an initial check, which is that the quality of original image should be better than the distorted images. So we found out 94% results match our expectations. So that's good. That means subjective IQA works well. And after that, we've been done the objective IQA, which conducted within MATLAB. We're using the image processing toolbox. So here we use 3 common and frequent non-reference image quality assessment models, including BRISC, Applied Reference-Less Image Spatial Quality Evaluator, and NAQ, Naturalness Image Quality Evaluator, and PEG, Perception-Based Image Quality Evaluator. So for the 3 mathematical model metrics, the lower marks the images get means the higher quality it is. So if the image gets higher marks, so that means the quality is worse. And we can find the table here. So here is an example of the image, which is a male 50 in the age group between 51 and 60 years old. And they have 3 pictures here, in which the first one is original and the second one is contrast distorted, and the third one is a blurry distorted. And we can find out that Brisk and Nick, these two models, didn't show very good performance in this set of group of images. And Pick may show the good performance in this image. So this here is example for these three metrics, but overall we found out that Brisk shows only 30% good performance in our initial check. So same as before, the quality of original image should be better than the distorted images in the same medical imaging group. And Nick shows 28%. And surprisingly, we found Pick shows 84% that the quality of original image better than a distorted image. So eventually we use the results from the perception-based image quality evaluator as our main result in objective IQA. And eventually with the compared results between the subjective IQA and objective IQA, and we found out that the results were similar at 80%, and also the Pick performed well in recognizing the distortion situation in CT scans. So from clinical results, we found out that sometimes the doctors are very highly sensitive to the changes of contrast value. And we also found actually the contrast, if a suitable contrast range can improve the quality of the images. So as the question before, so here is the range. We found out that the grayscale range for contrast can actually improve the quality of the images, which lowing is between the 0.1 and 0.3 and high in the 0.6 and 0.8. And yeah, we also found out within a fixed range of blurry degree, the distortion may not result in a negative effect. So which means actually sometimes a little bit blurry is acceptable for either clinicians or radiologists. And specifically, this range will be between the 0.5 and 1.0. And so for the future works, there's a drawback of this research is because we're using the MATLAB to process our distorted images. So one problem is actually the current distortion images may not just to follow the formula of the MATLAB. So there are many other types of medical imaging. So maybe future work can focus on the natural distorted image instead of the manual processed distorted medical images in CT scans. And yeah, that's it. Thank you for listening. And I would like to especially thank Dr. Lucy Lavic for her initial guidance on this research, because she's my initial supervisor in my bachelor's university. Thank you.
Thank you, Yuhao, for your presentation. So any other questions here in the room? Did you get all your answers, or or any questions on Zoom? Nope, no further question. Okay, 谢谢 Yuhao, 再见.
Thank you.
And so this concludes the QH session for now, and I think it's time for a coffee break on our side. So for online participants, I guess we can resume in 15 or 20 minutes, half past 3. Okay, see you then. Yeah.
Yeah, well, lots of my energy was.
Who would have known?
Yeah.
I asked you to take a photo here just for get.
Oh yeah, sure. Yeah. Tu veux
Can you wait for Lou? She's here. She's here.
Okay, maybe everyone. Sharon wants to take a picture here with all the guests, with all the. Sharing, did you mean here or? Okay, so come.
You can also connect using Zoom and make this special
Yes,
mode.
we can do that.
We actually did some pictures on previous.
Yeah, true. With the.
Myślałem, że wyświetlimy też w sensie parę uczestników online tutaj.
A, to było nawet fajne. Ale to by sobie można było zrobić później, jak będą.
So one more thing we could do is to show also online
participants with hand on the side.
But not now probably because you just send them to the coffee break.
Yeah. No, but after the coffee break,
when we start,
you can make picture. Hybrid picture.
I'm sharing.
Okay, if you want, I can make you a puppet.
Yes.
Okay.
Feel free.
Thank you.
With everyone's.
Okay, also with you.
Paparazzi.
There you go.
Thank you very much.
I will send it to the Big social group.
Sure.
I don't know. Are you there?
Yeah. Thank you.
So we are
Okay.
going here.
And we girl would sit here and what do you think about it? Only girls. Only girls, we want to sit here. Yeah, I saw her and I told her, sit here. And Lou, and there are some other girls also.
Ready for now?
No, okay.
Everybody should be here.
Yeah. But I would like Lucy
will not attend to the dinner.
Really? And would you please ask other girls to comment?
You want to put
Girl
power.
veulent faire une photo des filles
Name
avec
Girl power. Girls.
une photo des filles, juste des filles. Chirine. Oui, on est dans l'amphi en
Girls on the picture. Where's Jingwen? Oh wait, we have one more.
Wait.
And Lou, where's Lou?
Ah, on vous attend.
And
The
please.
girl over there, I don't know what's her name. Okay, à tout de suite.
Any more girls? Oh yeah, I don't know
Yeah,
what's her name.
She's coming with Lumi.
Oh
Okay.
yes, we have two more to come.
And one please sit here.
Should I? Okay. We have two more to come. You can do women and signal processing.
We could start a chapter of
Yeah.
Definitely.
And it would be really nice if Margaret and
Oh yes.
Yeah, I hope she
She can
will
join us
connect
some
this
point.
afternoon
Yeah, 'cause we
because
didn't she needs to present, no?
yeah, yeah, she.
Yeah, she didn't.
Vient d'arriver, je participe à la
Bien.
on attend le reste des filles.
We are waiting for Lou and Lumi. They should come at some point.
Sérieux.
Je sais pas, elle est où Lou et Lumi?
Elles arrivent, elles arrivent. Elles sont parties ramener les
comes
gâteaux.
soon?
Yeah.
Okay.
We can,
Women.
on
Yeah.
revient juste après pour la photo.
Okay.
Elles sont parties apporter.
Okay, coffee break.
Coffee to me. Thanks. And you are.
C'est pas grave, c'est pas grave. La prochaine. Yeah.
Yes.
Yeah, but I think he's wrong.
It's
Ah,
me.
c'est toi?
Ah.
So, but there is someone that is head of the lab or something like that, of your lab.
I found my lab in this website, but there is a response manager. I don't know. They said their side is
Ladies.
W
weekend.
And
W weekend.
This one it told me that I should not.
Can I come with my little dessert? Yeah.
This one. At that time,
مرسی ببخشید عادی مرسی
خیلی ممنون
خیلی ممنون زحمت کشیدین
I could not
I need to find this. We mean.
Lou?
No, where is Lou again?
She's coming, she's coming.
Ladies.
Sorry, that they're hearing us from online?
Women in
doing all of this
image processing.
The microphone is on, right?
Ready?
It's okay. Allez, Chung.
Andreas, bouge-toi, t'es pas une fille. Mais non.
One, two, three. Again. One. Let's check.
Thank you. I don't have chocolate on my teeth.
You are sending the
Oh,
people.
there is a problem. No.
Both of them?
No, yes, because there is a come. Lou,
But it's nice. It's like.
Yeah. I think it's okay. You can.
It's like a special effect.
Yeah, I think it's
we
okay.
can Photoshop
It's
it.
cool. I think it's cool actually. Send it to the
Group.
Big One group and say women equality.
So how to avoid this?
Yeah, I mean, like,
Can we turn off the projector? But then maybe you should come something like this.
Yeah. But then maybe you should.
Lower, lower. 因为这里正好有光的。
And from here.
I can.
A bit.
直接这样。
One, the two lights. Two.
I can't.
It's fine.
It's perfect. Thank you.
Yeah.
Thank you.
Thank you.
Merci.
Maybe I can compare with Maya.
Yeah, merci is the same.
You also use mercy, not
Yeah.
merci.
Well, we say merci. And you say merci.
Merci.
Wiesz, trochę można spróbować
In one day.
ale nie, no to ta struktura ta generalnie, ja mam wrażenie, że ta struktura jest, przedstawiasz matematykę, nie pokazujesz, że on działa. Mówisz o technologii, tak.
Okay. I will present here. So. This press try to align to this line. Yeah. What? That's fine.
I need to present myself. Next is not.
Nie, jest, bo jest na samym fakcie, że pokazaliśmy, że to dobrze oddaje temu mediom. To jest dokładnie to, co oni robią. Mówią, że taka jest matematyka, ale w ogóle to gdzieś tam. To się po prostu nie zmieściło. Tutaj ten obstaw nie wiem, czy jest aż tak bardzo ograniczony.
To zawsze można napisać, że to nie jest jedyne zastosowanie.
Chociaż oczywiście trzeba fajnie wpisać w abstrakcji ze względu na to, że no tak jak wiemy, przy refleksie to się zdarzy. No nie wiem, czy no i raz jak chodzi o introduction, to Liquid Scale is used to immerse research scale. No to jest taki step formal scale. Znaczy
Tak, tutaj jestem jest za to, że etykieta, a dlatego, że początkowy skalę interwałową.
I to w sumie można powiedzieć, że trochę będzie w kierunku, to jest mocno stosować, czyli nie jest taki czysty wstęp matematyczny. Tak, pytanie, czy to jest duży problem, czy to nie czy pewnie ja mam coś tam naprawdę, takie metryki mają takie ceny, tego, że w sumie patrzą w całą matematykę, już jest jeden rozdział po prostu, tak w ogóle to gdyby to trzeba było zmienić. Dobra, trzeba było dodać 3. Znaczy ten jeden to jest wyborem, bo on w ogóle ma jeszcze bo jeden to jest taki dobra,
No bo oni tam jak każdy to co mówisz, przeglądając się też
tak, ale dobra, ale zobaczmy, później gdzieś tu się zaczyna robić w końcu. Tu jeszcze mówimy o multimedia, ale to, co tu jest, handout solution, zastanawiam się, czy ten wstęp nie może zostać mieć wstępy być mocno. Tutaj mamy później matematykę, to jest no i tu już gdzieś to może być niebezpieczny wstęp, tu jest na pewno dobry
A możemy
Is that guy, normally that guy needs to validate your... and then
ten rozdział na pewno nie mówi, że
Why I want to use that many hours
distribution.
This is like a document that
Ale to jest to jest
like I need to sign that
for example. Ja przestawię.
this guy needs to validate yeah, but after you need the document, provide your IP address. So this is literally
We are like example, but also
so you need to check with provide IP and stable one that doesn't change. So now what we have also is we have a server where you can connect. Yes, because after when you connect to the SSH, who is connecting? The app will check the IP address of who's connecting. And to be secure, they only allow one IP address.
To, co mnie zaciekawiło,
zawsze sobie na wstępie tam tych, nawet tam tych dwóch dosłownie, ale po pierwsze słyszałem, że wydało się, że teraz to jest jedno, te papiery
Druga rzecz jest taka, że one w ogóle
no tak, no to
oprócz że były jeden z nich
Yeah,
I can't find
no, I tell you with my language, but I will have to read during the long session.
It's horrible.
Yeah. We'll be the next big thing.
When?
I don't know when.
And we usually going to work with business trip, 10 business trips for you.
But that was during
Gives you 20 weeks a year.
That's perfect. So the problem is that I could do better in my global so maybe I will do another call. Yes.
Okay, thank you very much for your break.
Oh, thanks, guys, for coming. Nice to meet you. Real life.
Yeah.
So let's find Nicholas.
Yes. Yeah. Force him to start.
So you can take the...
Yes, I'll do this.
It's like 1 million or something like this.
Yeah, to some extent, yeah. But I'm definitely more into classical physics than machine. It's like
Okay, so we start the recording and
maybe we didn't stop it actually. Yeah, we forgot to stop. Good afternoon, everyone. We are going to resume.
okay. Okay, so basically I was asked to be the acting chair of Norm because we miss all the 4 Norm chairs right now. And anyway, half of the norm presentations are mine. So, so that makes some sense. And I'm looking right now at the schedule of the presentations. And actually, I believe we have 4 presentations. 2 of those, as I said, are mine. And the remaining 2 are 102 and 105. And it seems that 102 is Vinesh Menon and Hadi Amirpur, and the other one is Hadi and Vinesh. So it's basically like same 2 people. So Hadi, maybe perhaps you could make the 2 presentations, in a row, because it would be just faster. Yeah, so maybe you can just take the floor, make the 2 presentations, and then I will make the two remaining ones. Okay? Is it okay for you? You will start, unless you want me to start. But you were scheduled to have the first presentation and the last presentation. But I think this will make more sense, to put them just next to each other. So you can take a seat here and. Make it short. Just maybe one more question. How much time do we have? Because we still want to fit the, I think, ITU affairs before. Okay, but in case she joins, how much time do you think she will need? Okay, so. Okay, so far we don't care that much about time, okay? Okay, but what is the cutoff time? I mean, what time we have to go to the restaurant? Because this is like really
7,
hard.
yeah.
Sorry?
I think we have enough time for the whole presentation.
Okay, great. So Hadi, take your time.
Thank you.
Half an hour per
Can you see the screen, or I should sit on the side?
It's okay.
Okay, because I'm quite tall. So. Okay.
Shall I start?
Yeah, please go ahead.
Good afternoon. My name is.
Yes.
Yes, recording. So my name is Hadi from University of Klagenfurt, Austria. On behalf of my co-authors, Vignesh is here. Also, Christian Friedman from Bitmove, and also Christian Timmerer. I will be presenting our recently released open source software, Video Complexity Analyzer, or VCA. First, I will explain about the motivation behind VCA. Features that are extracted by VCA are discussed, followed by experimental results. Some applications are explained, and finally, the presentation is concluded. In HTTP adaptive streaming, the same video content is encoded at multiple bitrate and resolution pairs, also known as bitrate ladder. And clients, based on their network condition and also device type, select the most appropriate bitrate resolution pair, and they watch the video. By extracting some features from the source video, we can answer some questions, such as where to encode, what bitrate ladder to select, and what encoding parameters to set. The state-of-the-art spatial and temporal complexity feature is SITI, but the observation is that time taken to compute SITI feature is quite high. For a 4K video, it is approximately 5 frames per second. It means that we can only extract features for 5 frames for a 4K video, which means that it's not suitable for live applications because it introduces additional latency. Also, in VOD applications, it will bring us the higher computational cost. In addition to high time complexity, the correlation with encoding bitrate, also encoding time, is low for SI and TI. So what is the solution? Motivated by this observation, we introduce Video Complexity Analyzer, or VCA, that can be realized as a fast preprocessor, that can determine the spatial and temporal complexity of video segments to aid the encoding process. So actually, our main contribution here is extracting some new features. So what features we are extracting? For a spatial complexity feature for a video sequence for frame number P, We split this frame into smaller blocks, block sizes W cross W, and for block number K, we calculate its DCT values, and then we introduce energy function or H as weighted DCT values. Just to calculate this energy function, we remove the DC or brightness of that block. So by averaging this energy function in entire frame, so we can calculate the spatial complexity feature. For temporal complexity feature for frame P, we consider frame P itself and its previous frame. So we calculate sum of absolute differences between co-located blocks in frame P and frame P minus 1. And by averaging this SAD values in entire frame, we calculate the temporal feature. Here you can see a heat map of our spatial complexity feature, also our temporal complexity feature on the left image, my left side. So there you can see heat map for the spatial complexity, and also on the right image, you can see heat map for the temporal complexity. For example, in this area that there are some hair movement, you can easily see that we have some temporal activity here. But about the experimental results, the main advantages that VCA has is it's about its speed performance compared to SITI. As I mentioned, SITI is only 5 frames per second, but having CMD optimization, also multi-threading, we can reach around 400 frames per second feature extraction, which can be used for live streaming optimization. So even without multi-threading, you can see that when threads is 1, we are still much faster than SITI. But with very regular CPUs, with 8 threads, we can reach up to 400 FPS for 4K videos. So to calculate the correlation, we encode 500 video sequences, all in tera mode, and then we calculate their bitrate, and we calculate the correlation between spatial complexity features, state-of-the-art SI, and our spatial complexity for 2 codecs, X264 and X265. And we can see that the correlation for E, or the proposed spatial complexity, is much higher than SI. So this seems that can be predict the spatial complexity of the video much better than SI. We also do intercoding using low delay picture configuration of X265 with different presets, very slow, medium, and ultra fast. And still we can see that E performs better than SI, and in most cases, H, or our temporal complexity feature, works better than TI. So we also calculate the correlation with encoding time complexity. You can see that H performs better than TI, but for E and SI, the performance is not that good. It shows that temporal complexity has much higher correlation with encoding time. But one very interesting observation, because Werner, I think, discussed this on Monday, that the correlation across multiple resolution is not good for SI. They had their own reasons. But fortunately, for our spatial complexity feature, it's not the case. So you can see that, for example, between 720p and 1080p, we have almost 100% correlation, which means that we can calculate this spatial complexity feature at lower resolution and even speed up the process of the feature extraction to around 1,500 frames per second. So which application we are using? We use quite in some applications this features. One of the first application that we use is for shot detection. We know that shot-based encoding can improve the encoding performance. So we introduce epsilon as the gradient of the temporal complexity. So we can see in the places that we have peak values, we can consider as shot boundaries, and we could successfully predict shot boundaries in the video sequences using this temporal complexity feature. The other application that we use is in online per title encoding. We know that in live streaming, usually a fixed bitrate ladder is used, fixed bitrate resolution pairs are used in order to avoid adding any additional latency. If we want to optimize this bitrate ladder per title, So we are going to add some latencies, but by extracting some features, E and H using the VCA, we could optimize our bitrate ladder per title because we are not adding that much latency to optimize our bitrate ladder. So as you can see in this workflow, we first analyze the complexity of video, then we select we determine the sync cuts, and then we adjust our bitrate ladder based on the content. So based on the type of the content, if we have a middle complex, simple complex, or very complex video sequence, we can have different bitrate resolution pairs. And here we can give one example for this content. We encode the same video content at 1.6 megabit per second, one for standard profile or fixed bitrate ladder, second using our online per title encoding. And here you can easily see that our per title encoding can improve the quality because it selects the optimized resolution for this content instead of using the fixed resolution, which is 540p for fixed bitrate ladder. But our online per title encoding can predict 1080p as the optimized one, and we can see the result here. So as a conclusion, VCA is a fast preprocessor, determines the video complexity features. So it's independent of all the codecs that we are using. So this feature shows higher correlation with encoding time, also encoding bitrate, and it can aid encoding process in the video applications. So this is open source software. If you are interested, so please have a look. Also, we encourage you to contribute to this project, and we will be happy to get your feedbacks on this. So thank you.
Thank you. Questions? I think you were first, Ali.
Thank you for the presentation. I have two questions, maybe more, but we can do it later. How does SITI and VCA correlate? Did you measure any correlation between the two?
No, I don't have this correlation between like SI and E, also TI and H. But what we have is just with here you can see that with encoding bitrate. I think this means that they don't correlate that much because E has very high correlation with encoding bitrate, but SI doesn't have. So it means that together they will not have a good correlation.
Okay. So we saw earlier during week that the SITI was expanded to high dynamic range videos. Is it possible to do something, or is it even necessary to do something like that?
No, we want to continue this project, so we are adding new features. For example, in version 1.0, we extracted only E and H for the Luma component. But in 1.5, we added also chroma components plus brightness of the video. So not only we will have the spatial complexity and also the temporal complexity, but also the brightness of each block, because this DC component in the DCT coefficient means the average brightness of the block. We also added that to our features, also chroma components, but we are also working on it to add more features in the future if it is needed. Yeah.
I don't remember who was next. I think
was there as well, but then maybe.
Yes, I think you could be next.
Okay. Thank you very much. Super nice, interesting, and nice show. I know that Norm is about to standardize SI and TI calculation. Do you think that it will be much more reasonable to standard this metric?
We are really interested in that, and I hope we will be able to do this because it seems that with encoding, I don't know the other use cases that they use for the SITI, but for encoding bitrate, also encoding time, which means the complexity of video for us. So this has much better correlation, also time complexity. So if it is possible, so for sure we are interested in doing that.
Perfect.
Because, for example, we use these features for other applications, predicting the time of the encoding, because sometimes we want to know where we should encode our video sequences, because we have like cloud-based encoding, and we will have, for example, different EC2s on Amazon, AWS. So we want to know that which EC2s we should use. if we could predict the encoding time beforehand, then we can optimize when we are encoding in large, in a scale. So with these features, we could predict like with 3% error only the time complexity of the encoding. So it seems that we have good correlation. So yeah, let's see that how we can proceed in the norm session.
Any other questions from the physical audience or the virtual audience? I don't see any questions, at least on chat. But maybe there are some questions from the. Okay.
Yeah.
Three.
Thank you for the interesting talk. I'm thinking about the real-time streaming that now we are working on it, and the big challenge is the latency, because it should the information, a lot of visual information should transfer via video and stream in real time, and need some overlay augmented shape on it. Anyway, I want to know that, do you think that this type of video complexity analyzer could be helpful to reduce it, or?
I think so, because I'm also thinking to use it in immersive media because it's quite fast. So for example, for different immersive media content, but I think it should, detect the complexity independent of the content that, the medium that you are using, modality that you are using. So I think it should work. Yeah. Because now also some people see that they are working on the game streaming, so they are using this, and let's see. I hope it will work. Yeah.
Any other doing?
When you calculate the temporal complexity, if I remember well, you calculate the difference between two frames.
First, we calculate the SAD between two blocks, co-located blocks. Like here, we have this block K, number K for frame P, and its previous frame, which is also the block K here. So we calculate the SAD between energy function of these two blocks. And then for other blocks, we do the same. And then by averaging, we calculate the temporal complexity of that frame. Yes, also I saw that in the norm, they are thinking about having this motion compensation stuff. So it will add some complexity, but yes, we are also thinking to add it to here in the future. Yeah.
And another detail is in the page
18.
Yeah, but with the correlation that you have, I really doubt that.
I don't say it's not. Yeah.
Yeah.
Yeah, here we have a hard sync out because we don't always have hard sync out because sometimes we have transition between two shots. We don't have a immediate cut and go to the other shot. Sometimes we have transitions between two cuts. This is what we have here, the smaller epsilon values. We can consider them as shots as well, but here we have hard sync outs. No, it's not first frame. It is the number 105. Yeah.
I think it's not related to these video frames on the top.
No, it's not.
Okay, so maybe
sorry, it was just an example. Sorry.
It's kind of misleading
just to show that it is a sync cut we have here and what we are doing. Yeah, it doesn't correlate to the result that we have.
Because I had same issue with that.
Okay.
Because there, you see something like a cut exactly in the place where there is really a cut.
This is for TOS sequence, but this was just one example, so I need to modify this slide. So thank you.
Okay. Annika.
You say that your metric, the spatial complexity is more or less independent of the resolution. Can you give us some hint about why you've seen the results?
Yeah.
But what's the actual reason? And also, I've heard about the SI, the traditional SI, but how did you achieve that?
Because even we lower the resolution and we calculate this DCT values, finally we are averaging it. So that's why it is independent of the resolution actually.
Because it's saying about an average energy per
Yes,
block.
yes, yes.
And doesn't matter how many blocks is there. No?
Yeah.
So understand that the block, yeah, of course, if you show the same resolution, upscale it, then there will be not the same complexity,
Exactly.
subjective complexity. Yeah.
But here we can see that, for example, for 720p and 4K, it is lower correlation. But the closer the resolution are together, so the higher the correlation will be.
The lower the resolution, the lower the details.
Yeah, exactly. That's why this correlation reduced in 720.
Any other questions? Okay. I see no questions, so I think you can just move to your second.
It would be quite fast.
presentation.
And just
That's great.
yeah. So the other presentation is about the video complexity data set we wanted to evaluate and also compare our features with SITI and
Just wait a second because it's not updated.
I don't.
No.
Okay, I got it. So I need to stop maybe sharing first. And
Seems like there is a delay.
no, I think I need to share the other page. So
Mhm.
this should work. Sorry.
No.
Yes, because we wanted to evaluate our features with SIT and even the other features. So we thought about creating a data set that we can have many video sequences, also their features, also their results. So our data set comprises 500 video sequences. So it includes UHD or 4K resolution, 24 FPS, the frame rate, 4:0 format at 5-second duration. All of these video sequences have this specification, and they are all stored in the number 1 folder, which is reference. They are all encoded losslessly, and we put it there. So we calculate SITI for all these video sequences. So you don't need to calculate it for this 500 sequences. We also calculate E and H, our VCA features. Also, we put them here. But we encode these videos at different bit rates, and we collect all the time complexities. The main thing that we have here that we encode them at various Amazon EC2s. So if you want to encode all of this video sequences in like, for example, C5x large, C5 4x large, 2x large, 9x large, and even other EC2s, it will take a long time for you. But we made it easy. We calculated on different EC2s, and then we put it in this folder that you can have access to different time complexity of different EC2s. We try different presets, very slow, for example, medium, ultra fast. We try different codecs, X265, X264. Also, we are asked to add VVC. So we are encoding with VVEnc, and we will have results, and we will add them here. We will have various rate control modes like constant QP, CRF, CBR, and this stuff. We are regularly adding, but now it seems complete. And if you are interested to work on that, so you have access to lots of data on that. The other folder contains the quality of these videos that we encoded. So we have VMAF values, PSNR values, SSIM, and other objective quality metrics here that you can have access. So if you are interested, so you can have access to this data set from this server, but we are very open for this. And if you have sequences that it's open to use, we would be happy if you share with us, then we can encode them and we can add to these folders. Also, if you have any specific codec or anything that might be interesting for you, please ask us. We will be very happy to do and add to this data set. For now, I think someone will share some game sequences with me that I will work on that to add here, to have also some video sequences for game. But if you have any other sequences, so we would be happy to get and encode and put it in this HTTP server. Yeah, it was quite short.
Questions?
We have very few sequences compared to your 500, but you know the ones in the check Ejeye with large scale data sets, which unfortunately are just tens of sequences. They are free available.
Yeah. So it's free to use?
Sorry?
It's free to use?
Yeah.
Okay, so maybe we can also add them.
I'll send you a link.
Okay, sure. Thank you.
Perhaps we also have some sequences, but we can talk.
Yeah, sure.
Later.
We have to.
Yeah, question, like when you mention about sequences, like a sequence or like 10 seconds that can be extracted from the same same movie, like of 10 minutes.
Yeah,
or
yeah.
is,
We had that cases. We segmented all of these sequences to 5-second segments. So if you have even long, we would be more happy because we will have more 5-second sequences.
5 seconds, but the cuts or always?
We have cuts there because one of the problems that we have with feature extraction, when we have cuts, it's really hard to predict the encoding bitrate or time because you might have a very less complex content in the first cut, but complex content in the second cut. But we included them to allow people to have sequences also with cut and maybe improve the results for sequences even with cuts. But we also want to determine this cut sync cuts for the sequences. So we will have a new label most probably that which sequence has sync cut and which sequence doesn't have sync cut. So make it easy for people to work.
and did you consider like a new project like AD1?
We are adding them. So now we are working on VVNG. So after that, we will add also AV1. Yeah. Yeah.
Are you distinguish the sync cut that's very like reaching SM or because we know that we can have the sync cut like just the camera move to this person to another person, but they are in the same room.
Yeah.
Same environment. Are you going to distinguish this?
It would be very hard, because we want to watch them and, by human, we want to do this because we have algorithm also, in sync cut algorithm, but I'm afraid it will not be like 100% accurate. So we would prefer to watch one by one and the sequences that have sync cuts. But you're right, I don't know, for camera movement, we should consider as a sync cut or not, I don't know. We need to think about it. Yeah.
Probably the model. Yeah, like typical sync cuts that are going from one to another through few frames.
Yeah, exactly. It's transition.
Transition. So this
yeah.
For those one you can mark the beginning and the end. That would be if you are watching them.
Yeah.
You want to make sure that where the sync cuts are.
Yeah.
I mean, you can mark the beginning and end. So it's a really useful information.
Okay, sure. Yeah.
Okay, any other questions? Okay.
So thank you very much.
Thank you. So that was the first half, let's say.
Yeah.
I don't know if this is the real half, but and thank you. So I'll move to my presentation. So I stayed alone here. Okay, so let me share the screen. I hope this will work. Not really. It says that my screen sharing is paused. And maybe I will try once again. That's strange. I can click to resume sharing, but it says it's paused. Okay. Yes, I've got like a.
Yeah, just the slide.
Yeah, but this is the. And it says like my screen sharing is paused, and I can click it, but it doesn't work. I don't know why.
It's weird.
I can maybe let's
send me your presentation.
I think
can do there.
I will try maybe one more thing. I will try to exit the full screen mode. Okay, and let's see if it works like that. Let me, where is my Zoom? It's here. So let me share, I think it's this one. Now it works, but it's not exactly the way I wanted to show it, but anyway. Okay. I think I will be able to go through the slides right now. I think it works. Okay. Sorry for the problems. So this is the first of the two presentations I'm going to give you here, but actually the second one is going to be very short announcement only, like 3 minutes. So this is the main presentation. So the title is the user-generated content UGC in the wild video content recognition. So basically, this is about the recognition of these two types of content, and it's a report of the work that was done by, well, besides me, that was also Lucian, Jakub, and also yet another colleague, Michał Grega, who is not here. Well, how can I move to the next one? I think, okay. So this is the outline of the presentation. So I will give you some introduction into this topic. Just wait a second, I can also move it here. Then I will tell you what the database we're used for that for the research, what was the modeling, and what are the results. And I will give you some conclusions and the plans for the further work. So let me start with some introduction. As we know, we have a very visible increase of the IP traffic right now, and it's like a couple of times more IP traffic since the last 5 years. And actually, most of the traffic is actually the user-generated content or actually user-generated video. And of course, the user-generated video is something that should be considered in a little bit specific way. I mean, you know, the way you compress it, the way you evaluate the quality is a little bit different. So you should know probably in advance what kind of video it is if you want to handle it. So of course, you know, if you have some metadata, that's fine. Then you can learn that this is the user generated or this is the video that was made professionally. But sometimes you simply don't know. So our idea was that maybe we can introduce some algorithm that will detect, you know, this kind of content automatically. And the point is that actually some of the user-generated content is really hard to distinguish from the, let's say, professionally generated content, because nowadays you can buy a very high-end equipment for the quite reasonable price and also generate content. So actually, we use a little bit different term. We don't call the content the user-generated content, but the content that was recorded in the wild. And in the wild means that there is a content that was shot without, you know, special staging, illumination of the scene, and without, you know, the very, very high-end equipment. So in order to give you some examples what this content could look like, here are some examples, and we actually focused at news recordings like newscasts. And actually, this is not like a clear distinction between, you know, the user-generated or in the wild content and the professionally generated content, because what you can see here is like the gradual, you know, let's say share of the professionally and the user-generated content. Like, let's say that the picture A is the clear professional content that has no, let's say, in the wild component. While, for example, at this B picture, you already have this professional, you know, studio shot, but there is a screen showing some Skype connection, which could be considered like a, you know, the user-generated content. And then you have another, you know, a picture like the C, and here you have the studio shot, but there is a screen, you know, which is a very large one in the back, showing some user-generated content or in the wild content. You could also have like a digital mixture of these two types of content, like on the picture D, when you have like, let's say half the in the wild and the professional content. You can also have like the here on picture E, that the majority of the screen is occupied by the in the wild. However, you still have some professionally generated frames or whatever. And of course, F is like 100% user generated or in the wild content with a quite low quality and so on. So of course the distinction is not easy, but of course at first we tried to distinguish between those two very evident cases, and we tried to find some video sets that will already have both user generated or in the wild content and the counter sets with the professional content. So we investigated these 6 databases that are listed here. And actually, they all call themselves user-generated content, but it doesn't mean that all of this content is in the wild content, because sometimes you can find, the really high-quality content that is, well, technically it was made by users, but it's completely indistinguishable from the studio content, right? But we were able at least to use some of those sequences from these databases. I will mention this a little bit later. And as the counter set, we use the NTI simulated news dataset. I don't know if you are aware about it. This is the simulated news that was shot by colleagues from NTIA. I think that was Margaret Pinson actually, and is available on the CDVL database. So it's not real newscast, but it really looks professional. I mean, it was simulated, but it looks really professional. So actually, we only used part of this content. So we used the Convid, that was the name, is the Convid database, and of course the CDVL NTIA user NTIA simulated news. And since we learned that the content type within a single shot can be only of the one type. I mean, a single shot can be either the in the wild or the professional one. So everything was based on the shot basis. So we were just like splitting the whole content into shots. We use the PySyn detect, which is like a Python module that is commonly used for shot detection. And we split, the whole content into shots, and we averaged some values of the, let's say, content indicators that we used for this purpose. So at the end, we got like 68 shots with the professional content or the simulated professional content, and more than 2,000 shots with the in the wild content. But we actually sampled the set of the in the wild content in order to keep it more balanced. And for the analysis, we employed 10 of the so-called video indicators, and many of you probably could know it. I mean, we have developed a couple of years ago. We have developed a set of video quality indicators, which are the no reference indicators that analyze pixels of the video frames and provide some information about the content. If you're interested in, I can point you to the link where you can download actually this software. And we selected 10 of the indicators that actually, it's not like they were meant to work in the task for the recognition of professional and in the wild content, but we're interested in if we can use it for this task. So actually, we just made an experiment asking this question by ourselves, and as I told you, we averaged the values of these 10 indicators per shot. I mean, per all the frames in the shot. So for each shot, we had a vector of 10 values that were the averaged values, and then we also employed some procedure for normalization of the values. So we used, I mean, for each indicator, we either kept, the values in the original form, or we applied truncation or logarithmic scaling and normalization from 0 to 1. And at the end, we employed the decision tree and random forest modeling in order to check if this is possible to recognize these two kinds of content. So this is the table showing the normalization procedure. So for some of the indicators, we use the logarithmic normalization and the truncation, and also for, and here you have the values of the individual cutoff thresholds. So these are the results, which are quite good, actually. I mean, the accuracy for the decision tree modeling was really high. I mean, it is like 95, 97% in terms of, I mean, it depends on what metric you are looking at. But let's say that the error rate was really low, and we also calculated precision and recall and the F measure. We also made like a second approach, like we tried to see what will be the accuracy if we not test the model based on the test set. The test set, by the way, was 20% of the original set, but we tried to see, if we employ our model on the whole set of the user-generated content, to see, in how many cases we will fail to classify it correctly. So, by the way, of course, the precision was always 1, because by definition it must have been 1, because we only use part of the, I mean, the positive part of the set. But we're able to see how many errors we're going to have, so it was also quite high. And what we learned was that actually the indicator that was really strong in recognizing the content was the flickering indicator, which was completely not meant for indicating the user-generated and professional content, but somehow it worked here. What is a bit funny, but that's the fact. So this this is the whole decision tree we found. And with random forest, the results are even better a bit. I mean, because of course this kind of modeling is let's say usually a bit more powerful. So of course this is the kind of work in progress, because the set was quite small and there were only 2 databases used. But of course we want to achieve the results based on the larger set. So far, it's quite promising, but the set was small, as I have mentioned. And the idea is that we want to test it on much larger set of videos. We have downloaded something like 6,000 YouTube clips, I mean news clips, and we want to test it on this kind of, well, I don't know if we're going to test it on the whole 6,000 newscast clips, but at least a subset of it. I mean, to have a much larger set of videos. Okay, this is like everything. Just to mention that it's actually like the rehearsal of the presentation I'm going to have at the 14th Asian Conference on Intelligent Information and Database Systems, that is going to be organized in November this year. But you have the sneak peek into the presentation that I'm going to have this autumn. Okay, so are there any questions? Please, Ali.
You said you worked on individual shots.
Yes.
And in some of the examples you showed there were a mix of in the wild and mix of professional content, especially like news content, where there is a huge overlay on the videos. Basically, in these scenarios, I thought it would be a bit difficult to see the scene cuts
Yeah.
Because the scene cut can maybe happen in the large screen in the news room or newsroom, where the majority of the overlay will, of course, won't change,
Mhm.
and you may not be able to identify it. How do you treat these cases? Are they common?
Okay, so these are actually, these are the screenshots from videos that we have downloaded from YouTube, and I placed them here only for illustrative purposes because we actually haven't used this particular, shots. Maybe that was a kind of misleading thing, but in the experiment that we made so far, we had a very clear in the wild and professional, professionally generated content clips. So that was quite obvious. The problem is that with those shots, sometimes you have to really annotate this, and if this is not like the A or F, actually, you don't know how to annotate B, C, D, and E, right? So it's likely that we will just not use these shots in the research because anyway, at the end, even if we annotate it, this will be quite subjective annotation, and well, even the answer of the model will be quite ambiguous.
So clearly they were not concerned in the data set.
Yes, I mean, this is actually one of the biggest problems that, even if you normally you can find this, databases of the user generated content, but if you look closely into this content, actually, I mean, it's not that obvious that this is really a user generated content. I mean, you have many elements coming from the really professionally, generated studio clips, and so that's why we only used one database out of these 6. Because it was not obvious for all of these databases if this is really the content we are looking for. Okay, any other questions? Is there anything from those who are online? Maybe I can take a look at the chat, but I don't see anything. No, I think there is nothing in the chat.
Yeah.
Yes?
Did you perform other analysis that, because I guess you have different type of resolution in your data set?
You mean the
like a per resolution analysis?
I believe the resolution was probably same. In this case, I think that was either 720p or 1080p. I don't know, Lucian or Jakub, do you remember the resolution?
It was different, but I think that at the end we use mostly full HD.
Okay.
No, because in the other data set there is a variety of content.
Yes, but we use only one database among those 6. So yeah, but this is like there is a lot of further research planned. This is
because based on like you say that blockiness or flickering was a good indicator. And why? Or is there any?
Actually, there was one indicator that was even stronger. That was the interlace indicator, but we thought like we should exclude it, because we should not train the model on the interlace, because you can have interlace both in the professional content and in the let's say user generated content, right? So we didn't use all the available indicators because we don't want to to overtrain them on let's say on the interlace. Yes, sure.
No, I was just thinking, wouldn't the interlacing be like a very good indicator? That what type of user cameras would give interlaced content?
Yes, but on the other hand, it's not like the professional content will be interlaced. I mean,
yes.
I mean, for example, these clips downloaded from YouTube, and this is those clips are downloaded from the official channels from of the TV stations, and it's only some of them contain interlace.
Yeah, I mean, most still most sports content are shot
Yes.
in 1080i.
Mhm.
Sports content is
Yes.
is a rather big part of the
But we are focusing at newscasts actually, and for newscasts, most of the content was actually, I think, well, it's hard to say this is most, but there was a high share of content that was not interlaced, and it was I think it's like, you know, maybe TV stations, you know, they air the content in the interlace, but they post the same content on their YouTube channels without the interlace. So maybe they produce two very, yeah, because, you know, probably it doesn't make sense to post the interlace content on YouTube to have all these problems with the interlace.
So this should only work for content that you can download from the internet.
No, but, you know, if we made it like based on interlace, that would only work on the content that is aired. So if we are like interlace agnostic, then I think it's more universal.
Yeah, that's fine. I was just surprised. Okay. Anyway, that's good.
Maybe it works longer. If it is interlace, it should be.
Yes, I mean then.
Yeah, that could be like, yeah, that we first have the filter saying if this is the interlace, and then, you know, the second phase would be. Yes, that's a good idea. I think there are like 2 questions on the chat. I think there is Margaret saying that I pointed out a definite missing dataset content of mixed wired and professional video. Do you plan to make a data set with this type of content, or use internally only, or neither? I think, you know, we probably can post the content as long as we have, you know, a copyright, because if we download something from YouTube, usually this is copyrighted. So I think maybe we can point the links to the content and say people like, please download the content by yourself. Maybe we can even post some, you know, Python script that will do the work, but we should rather not post the content itself, because I don't know if this is legal.
Yes, but
Yes.
Maybe just so very quick on this point, like when you upload the stuff on YouTube, you can choose between 2 licenses. One is Creative Commons Live, that basically means that anybody just decide that the content downloaded from YouTube and you can use it. But I don't know.
Yes, but I mean, as long as we refer to the 6,000 videos, I think the vast majority of it will be using the YouTube license, because that was already posted by TV stations like BBC or, I don't know, Euronews or whatever else. And once we download it, you know, okay, maybe we can use it for the research, but we should not repost it back to YouTube. Actually, I think YouTube can even remove it or ban it, because they have some algorithms for that. Jakub, I think you had a.
Yes, I wanted to say that internally we do use just URLs
yes.
to index the videos, because in the YouTube URL you can also specify a timestamp, even the start time and the end time of the playback. So
yes, but
maybe one solution.
What we can do is, like, if we find a data set that is like UGC, but not necessarily in the wild, and if it is made like free for the research and posted with some open license, we can maybe, you know, make a subset of it and repost it somewhere. Okay, maybe pointing to the original one. But, you know, if this is the already free content, I think we can do this. But I would probably refrain from, you know, doing this with the, let's say, commercial content. I think there is a question coming from Steve, who says, I may have missed it, but the professional content is only news show content. If so, what about including more movie-like content here? Netflix, El Fuente, and so on, or AVT, VQ, DB, UHD1. Yes, that could be an idea. Just we started with the newscast just because that was actually the background of the project that this research is involved in. So we've been mainly targeting newscasts newscasts, but of course this is possible, but simply, yeah, let's say the envelope project is about newscasts, so that's why we use newscasts. So okay, and I see some more questions. There is Nabajit asking if you can share it on per request basis, like a Google Drive or Dropbox or Box file that should take care of copyright issues. Yes, I think, I mean, the content is there, I mean, at our servers. So if anyone is interested in getting this content, by the way, of course, you can target me or us directly and we can share it. That's absolutely okay. And Steve is saying that our focus on CC0 license YouTube videos. Yes, but I have already mentioned that this is already, I mean, the content was already posted with the YouTube license. And Nabajit says that is what probably Live did. I mean, Live Lab did. Yes, that's right. And I think Pablo says also for your next step, when you are tagging ambiguous content, you can check this paper from last week, ACM, jury learning, integrating dissenting voices into machine learning models. Okay, I'm not aware about this last week paper. So,
pretty sure. Sorry, I was just attending the CHI conference last week, and it was a paper about how to handle when you have ambiguity in the tagging of models. So you have like different people tagging and they disagree on the tagging and how to introduce that information into the model. I don't know if it makes sense to you or not, but you can take and see.
At least I believe I should read this paper. So actually, I may ask my colleagues to make a note about it because I cannot make a note right now. So Jakub, Lucian, if you could make a note of that. But yeah, so far we had just a very simple idea how to make this tagging, but of course, following some more professional way would be beneficial, definitely. Any other questions? Okay, I see none. So that would be the end of my first presentation, which was like the main one. And I still have another one, which is just like an announcement, but I need to change my slides. So just give me a second. And okay, probably I will have same problem as with the previous one. So I have to leave the full screen mode. Okay, and now I can share it. Okay, I hope you can see it. This is just a very short introduction on the project that is just right now starting at AGH. And we have like two completely distinct targets there. One is quite maybe close to what Norm is doing right now. And the second one is probably not that much relevant, but this is going to be like 3 minutes. So anyway, I will make you listening about this. So the first thing is that, you know, as I have mentioned before, we have developed a set of indicators. This is like 15 or even 16, I believe right now, indicators that are posted online, so you can download this software and play with it for the research purposes. But what we found is that there are some issues with some of the indicators that are related to the sensitivity to the resolution. So sometimes it's like you cannot use these indicators and you cannot compare, let's say, 1080p and 4K indicators because they have completely different range of values. This is what Norm is also realizing right now, and what we will try to do, we'll try to make those indicators resolution agnostic, let's say, to allow people to really work on completely different resolutions. I mean, when we had like mainly 780p and 1080p resolutions, that was not a big issue. But right now we have 4K, we also have 8K, you know, in common. So I believe if something must be done with that. So we are going to work on that issue. So I hope we can bring maybe some added value to Norm. Unfortunately, there are no Norm chairs here, but maybe I will also mention this during one of the Norm calls. And the second thing is that we plan to introduce some kind of software as a service, let's say, proof of concept of the demonstration that will allow people to calculate, some video indicators just based on some web-based interface. So instead of, downloading the software and running it, I mean, we also work on the Python package right now, so you could import it into Python. But I know that even Python package could be not easy enough for some people who are completely agnostic to programming. So we plan to develop some web service, so you could just drag and drops, the video from your desktop to the web page, and you can get, the quality indicators like SITI and other stuff like that. So for some people that are interested in this, let's say, short results and making research in a very easy way, that could be a bit beneficial. So that was just everything. That was just a short announcement. So if you were interested in, I can tell you a bit more. I see two questions actually coming from the chat. Okay, Shahid is asking, is there an indicator to judge the resolution of the video? I mean, you probably referred to the intrinsic resolution. Actually, once we tried to develop one, but that turned to be not an easy task actually at the end. We called this granularity, and I don't know, maybe someone already did it, but at the end, we, honestly speaking, we failed. So there is no indicator like that. Maybe we'll come back to this issue, working on the, on the problem that we found right now. But so far, well, there is no indicator as such in our pool of indicators. And okay, the second thing is then coded resolution. I mean, even if there's okay, so this is the same thing, like how to detect the resolution if you upscale and downscale the video, or if you downscale and then upscale and what is the actual resolution of the video? Yes, Jakub?
I remember there is a patent submission by Ioannis Katsavolidis, exactly the solution.
Okay.
It's able to detect the resolution.
Okay, so
patent protected.
Okay.
I'm not sure if you can use it.
Yeah, I mean, there could be, but I haven't investigated it. So, but a couple of years ago, when we tried to attack this problem, there was no really working solution, and we tried to develop one without the success as well. So, I mean, it was not stable enough. Okay, Ioannis had some presentation back in London. Okay, maybe. Could have been. I mean, maybe I could miss it. Okay, Maria is no. Okay, this is not the question. It's just a comment back to Shahid. Okay, so are there any further questions, comments? If not, I think we can wrap up the norm session.
Maybe, sorry, not sure if you can hear me today, if it's better than yesterday.
Hello, great to hear you.
Hi. So yes, so some global comments. First of all, I've enjoyed Hadi's presentation, both presentations, of course. Hadi's one, I'm talking about Hadi's one because this is more related to what we are doing. I think it was very interesting and can be useful, and also the way to present the results, I think, was a good example. Also for our students, how to present results. Something I wanted to comment is that we have worked on some alternative methods for spatial and temporal.
Maria, we have problems understanding you. I mean, your voice cuts every second. Something.
Okay, I will try to type. It's a long comment, but I will try to type, or maybe send an email later, or
No,
Okay.
actually, now when you spoke louder, it was okay.
Yeah, maybe you can try once again, but get closer to the microphone or.
Okay, let me move a little bit.
Okay.
Is it better this way?
It is better.
Yes,
Yeah.
a bit better. Yeah.
Yes, I was commenting about Hadi's presentation that I have enjoyed. I think it can be very useful. And also, I want to mention that we had done some work. Unfortunately, I didn't have time to collect well the results and prepare the presentation for this meeting. But we have some indicators which can also be suitable for the content characterization. They perform better than SI and TI. Definitely, we had very good results on 1 and 2 data sets. They are not general. And we recently have asked Shaima, the researcher working on this topic, to test Hadi's one, and I can see they perform very well as well. So depending on the data sets, we have performance which is better for those parameters.
We stopped hearing you, unfortunately.
Okay, sorry for that. By the way, maybe in short, I think it was very good was Hadi presented. I'm happy to contribute in this direction to the work of Norm and some other potential indicators for spatial and temporal complexity. I hope I will be able to present this. It was too early to do it in this meeting, but probably in 1 week time, we'll be able to present them and have results for wider data sets. I was also interested in the data set that was mentioned by Hadi. So we may decide to use it to test our metrics as well.
Thank you. Any other comments or questions? Okay, so thank you once again for your attention, and I think we can close the Norm session, but yet we are not closing the VQuick today's meeting, because I think Shell, you still want to talk about these ITU activities, right?
Yes.
Okay.
Still on the agenda.
Okay, so I will just leave this place right now. After shower?
Should we
do a 10-minute break? Or?
Do we need a break?
Can we?
10 minutes.
Depends on how long.
Yeah. How long
I mean, if it
your,
is like 15 minutes, let's not do a break of 10 minutes.
How long is your discussion?
I don't really know. I think we can go on as long as we need, but
Okay,
it's
so
not.
maybe let's
I will take the help of Margaret actually to do this, because it is more like our work that we should try to drive. So I will change place. So that's 5 minutes break, so I can get settled.
So do we make like an official break or just like running
Maybe
break?
maybe an unofficial break.
It's running break. Running break.
Scroll down quickly. Try test and read the papers very fast. Scrolling. Yeah, exactly.
Margaret, are you online?
I am. Hello.
Hello. Nice to hear your voice. So how do you think we can do this in a best way? I mean, I can try to pick up any comments and suggestions from the room, but I think you can equally well lead the discussion as I can. And I noticed that I don't have, I'm not sure I found the link to the document, so maybe I assist you in running the discussion. Would that work, do you think?
So the document, I will get the link while we're on break and put it in chat. I can describe each item. I was just thinking it would be easier for you to coordinate discussions.
Yes, yeah, I mean, I can, yes, because I would have the view of the room and Zoom. So sure. So let's see if we can drive this together. So I need to get my computer up to speed again because I had to shut it down.
Me too. So fortunately, there's a break. And to answer the question somebody had, there's a lot of items in this document, and based on the previous meeting where we discussed it, I suspect that there will be a lot of issues people want to discuss. So I think it was wise to take a break.
Yeah, okay, it's very good.
Sorry, I was switching devices and apparently
Yes.
didn't do it very smoothly.
Okay, now I joined with my computer as well, so can see the chat and the participants. So whenever you're ready to share the document, we can try to get people into the room again.
Okay, I'm still looking for the link.
So then I'm not surprised I didn't find it myself this morning. I go quickly to the restroom and come back.
Really, you cannot go, no? This totally will collapse.
Everything will go sequences starting from special sources, so it's very different parameters and so on. But I didn't want
Okay, I'm back. Then I see the document is up, so I will try to get people into the room again. Okay.
Okay, wonderful.
Okay, we should start. Please, can we get back? Why is that not out on the screen?
I put the link to this online document in the chat if it would work better for you to share, Shell.
No, it's. I don't think it's. It's visible on all the computers, but it's not visible on the wide screen. But that has nothing to do with me sharing or you sharing.
Okay.
Because the screen sharing is done through Zoom anyway.
Les Français au niveau du PC, ça s'est annulé. Ça s'est fait trop longtemps.
C'était ça qu'il avait fait tout à l'heure, partage de plan.
Oui, mais il ne faut pas cliquer trop de fois. Il y a un télé énorme.
Is it the right? I mean, this is B. Is there another source like A? Or...
Oui, personne n'a.
No,
Nobody touches this.
No.
No.
Okay. Can everyone see the document on your own screen?
Does it work on Zoom?
I mean, it definitely work on Zoom.
Okay,
So
yeah.
so
maybe.
so okay. Let's start. So no, a Google document. You don't see it? Yeah.
We do.
Okay. So Margaret, you can go ahead. I would.
Okay, thank you. So there's a lot of experimentation and learning people from VQuag have done on how to design and conduct subjective tests since ITUT recommendation P913 was approved. And I think it's time that we write down all of what we've learned and update P913 to include this expanded knowledge. And so this Google document has everything I could think of, and I'd like to run all of these changes past the VQuag experts before putting a contribution into the ITU or a VQuag liaison, one or the other. The goal being to update P913 and improve it. So the first area is the duration of stimuli. P913, oh, and as a quick aside, why not change the others? BT500 is the oldest, the best known, and it's also the slowest to change. And that's between P910 and P913. Our initial thinking when we wrote P913 instead of changing P910 is that the previous time somebody had asked for major changes to P910, there were objections and the ITU was unable to modify P910. So the idea with P913 is to make a document that people are more willing to make changes, to put in new techniques that are suitable for modern technologies. So in P910 currently, the duration of stimuli recommended is 5 seconds to 20 seconds. And the data sets that I've created at 4 seconds works well. And there's a lot of experimentation into longer sequences of 1 or 5 minutes. And so I think it's really time that we add those shorter and much longer sequences. So the proposed change in is the
mute if you're not speaking.
So on the screen, and my apologies to anyone who is red-green colorblind, hopefully it stands out well enough. The text in red is the proposed new text. The text in black is existing text. And so these are the proposed changes. First, to change it from 5 to 20 seconds to say it's intended for 4 to 20 seconds, and then adding details, starting with caution must be taken when using stimuli with durations longer than 20 seconds, adding 4 references to publications, one from Shell that we haven't entered the details of yet. And then saying that these, the 3 papers from 2015, 2018, and 2020 demonstrate successful applications of the 5-level ACR method for stimuli between 1 minute and 5-minute duration within the context of quality model development. Tests with 5-minute duration media can be very enjoyable if the media have audio. And I'll hand it over to Shell for discussion.
Okay, do we have any comments or questions here in the room or online?
Yeah, I made a single comment just in terms of readability, because I believe in the SI Unix system, M means meter and not minute. It's just confusing to see here.
Yeah, you're right. You should write minutes. Yes.
Thank you.
And there is one more.
There is 5 minutes there, not 5 meters. Okay, we have a comment from Nabajit.
There is one, yeah.
In passive spectator gaming, we use 30 seconds videos in general. We can probably add that too.
Nabajit, could you put a paper reference into the chat or add it to this document later? And let's see. Oh, and P809, does that also show longer sequences?
No, not really. So basically, it's the same that Nabajit mentioned. So I just want to mention that this 30-second, you can find it actually there. So because you asked for the reference.
Okay. But does it contain supporting proof for demonstrations of successful applications of ACR with 30-second stimuli?
So in the recommendations, surely it doesn't, tells you any proof of that, but I think there are some references that can be directly taken from there. But anyway, that's a recommendation. So.
Okay, so you're saying add it to this list, sure.
Yeah, sure.
But isn't it quite recent that the ITU started to add reference into the recommendation?
Okay, any other comments on this?
I don't see any in the room. Anything online? No?
Okay, so here's the next one. So this is work that I presented 2 years ago in VQuag on a confidence interval for a subjective test. And this is an issue where we haven't done much of discussing of during the SAM group. But anyway, the idea is to reference this way of calculating subjective test confidence intervals and then give some guidance based on the measurements I took of close to 100 data sets to help people understand the expected precision of subjective tests. So the text in red is new. The text before it is already in there. This would go into the part of P913 that is specifically talking about the ACR method. And I'll read the proposed text aloud. We have gone through and made some edits at the last SAM meeting. The following statistics characterize the expected precision of a 5-level ACR test. let us define the subjective test confidence interval, delta SCI, as the minimum difference in Moss values where 95% of the stimuli pairs are statistically different according to the student's t-test at a 95% confidence level. A subjective test's delta SCI is measured using subsets of stimuli pairs that have similar mean opinion score differences. For example, 0.1 plus or minus 0.05, 0.2 plus or minus 0.05, etc. Measurements in the reference from 2020 indicate that the ACR method rarely yields delta SCI below the following values: 0.5 for 24 subjects, 0.7 for 15 subjects, 1.1 for 9 subjects, and 1.5 for 6 subjects. Unexplained factors in the experiment design and implementation may produce delta SCI up to the next category of subjects or higher. For example, 24 subject tests typically have delta SCI between 0.5 and 0.7. The size of the confidence interval depends on the post-subject screening method. More advanced data cleansing methods like clause 12.6 may reduce the confidence interval. And clause 12.6 is referring to the MLE method that Z has been talking about over the past few years.
Any comments? Questions?
Yeah, I will repeat myself to some extent, but I think that this is worth saying that those were mostly video tests. Margaret, am I correct? Because we know that
actually, this was a mixture of video tests, audiovisual tests, image tests, and speech tests.
Okay, so we have really everything. Okay, so maybe we can leave it like that.
Yes, and I did not see any significant difference between these different media. It's really seemed to be a characteristic of the 5-level ACR test method.
Okay, I see no more comments here.
Okay, so I'll go on to the next. So in this case, all of the text is new, so I didn't mark it in red. And this is referring to a skip option. So in P913, as with most tests, usually the subject is forced to give a rating. We know that occasionally your attention wanders during a test and you just don't see it. And in that case, we're forcing people to give a corrupt vote. So instead, I have for a couple of my 4-second video duration tests given a skip option and analyzed the results. And I was pointed to a paper from Werner where he took a different approach to do the same thing. And there was someone else who was on the same call who said, pointed out that they let people rewatch in such an instance. So the proposed new option is all around this option, an acceptable change to the method where you address the situation and give the subject an option other than giving a random vote. So the proposed new text. Any rating scale may be supplemented with a skip option. When selected, the stimuli will not be rated by that subject. Subjects are encouraged to use the skip option if they are briefly inattentive and did not observe the stimuli. The stimuli will either not be rated, i.e. a missing value, or put back into the playlist to be randomly presented later in the session. The skip option is highly recommended for short sequences, for example, 4 or 5 seconds duration, and the FOWR protocol, see clause 9.5. Table 5 of the ITS4S reference, Table 6 of the ITS4S3 reference, and Table 3 of the ITS4S4 reference provide statistics on the frequency of subjects using the skip option for 4-second stimuli. Werner's reference provides statistics for a skip option expressed as a 5-level scale where subjects state their confidence in having provided a reliable rating. Any rating scale may be supplemented with a watch again option. When selected, the stimuli will be presented again to the subject before they rate the stimuli. The skip and watch again options could complicate difficult tasks, confounding ratings and possibly impacting the ratings. Sorry, confounding the results.
Okay.
And below it,
so my proposal is that to add that those skips should be recorded in the data. Like I understand that the standard doesn't say that you should share the data or something like that, but at least putting it here that whatever software you have, the software should record that someone skipped, regardless of what the getting random forward or just we just skip the recording of the data. Whatever happened.
okay, like that?
The recorded data should indicate that the subject used skip again or again.
Oops.
If option. Yes, maybe adding regardless of the method. Yeah. Thank you.
Sure. I'd like to move away from the word should, though. I've been told that the concept of should does not translate into some languages.
Oh.
Would you be okay with must instead?
Totally.
Okay.
Yes, go ahead.
I do like the warning that is at the end, but I don't know how it translates to other places. That is more of a question. In the sense that we are indicating that this can be supplemented, but it can be confounding someone reading the recommendation and wanting to implement that. What is the thing? So that it was more, I think that there was a comment a few days ago about recommendations being more clear and not more vague. So I don't know if this translates to us.
Did you hear?
Okay. No, unfortunately, I could only hear a little bit of what was said.
Could you repeat so we can repeat?
Yes.
Maybe it's easier if we repeat like closer to the microphone. Right?
Let you already try to summarize it in writing on the text, or maybe you can refer to the text.
Okay. Did you see the chat, Margaret?
Irina says that she likes the wording at the end, but it looks more like a question than a recommendation.
It should be more direct.
Yeah, the idea, in general, the idea is that the recommendation should recommend and not saying that there are many options and you should think about it.
Yes, that's a good point. What's
But is that good to have in a recommendation?
I mean, I like the sentence, but like we make things more clarity. Maybe this is how it is. Try to, it's not like obvious.
Try to put yourself into the shoes of someone who is reading it and trying to plan an experiment.
Yeah, what defines a complicated task here, for example?
Yes.
For me, a complicated task might be quite difficult than what you would think is a complicated task.
Yeah, I understand that something very concrete would be writing something like, if in your task option skip was used in 5% of the cases, it means that your task is complicated and people overuse it, and then you should consider to rerun the test without that option. But then we have to kind of magically find out if 5% is reasonable or not. But maybe this is why it's a standard, and if we put this 5%, then, well.
But we put that referring to...
a lot of things in standards, what I learned by the years working with the big web are guessing. So,
this is what experts are about.
Yeah, here this would be nearly blind.
so? The idea behind this was that the skip and watch again options are not appropriate for complicated, difficult tasks, because it could make it more difficult instead of easier.
Can you give
that you have,
of a difficult...
Maybe we could just reword this. Let me write a proposal and see if you like it better. Okay, that's a rewording that's more closely aimed at the original objection that was raised.
I have a comment.
Jakob has a comment.
Yes, so just yesterday, Dietmar actually showed the presentation where they used the skip option in a subjective test where they were aiming at detecting very small differences between images. The differences below 2 to 3 J and Ds. So even though it was an intentionally difficult task, they did use the skip option, and the subjective test was successful as far as I remember.
Okay, so you would not like, so you don't agree with this flat out?
Okay. I wouldn't remove it, I'm just adding the, yeah. I just wanted to show a counterexample that sometimes, even if the task is difficult, you can use the skip option and it works well.
Yeah, I would say that I like the description much more, because I fully agree that before this difficult is pretty unknown, like you said. So this description is better. The only problem is that now we are really targeting something specific, because we starting to define difficult task, and we know that it's actually not the case, yeah, because we can use skip option for this task.
Then now everything may come down to comparing it to the difficult example that we give here.
Yeah.
But this is not the threshold probably for a difficult task.
Yeah.
Yeah, there is, I think, no easy way to handle this, but I also agree that this version is better than the previous version.
Okay. Could we change from the skip options may not be appropriate instead of are not appropriate?
I wondering if we are not, if maybe what we wanted to say actually is that using this option should be monitored and analyze if it didn't make your task more difficult for the testers or being overused for the testers. Because this is, I think, this is the true what you want to say. Yeah? That it's not enough tested that we can say yes, add it everywhere or use it those cases. Like, and then we are kind of safe. Let's show that the fair comparison is okay, then with small differences.
Okay, so you're proposing we start by saying that directly, that these options should be monitored. For example, report frequency of use and analyzed for overuse and misuse. What other text would you like to retain from below?
Well, I see that I hear differently from you that Irena still is not very happy with this sentence because of.
I'm just commenting on the fact that I agree that it should be monitored, but are we giving any recommendation on how to monitor it and how to analyze the overuse and misuse?
Yeah, so again, Irena is going into direction like if we do a recommendation, we should say something more about what does it mean the monitor or misused or overused. Ah, this is nice.
Yes,
this
like,
sentence is very good
yeah,
because it will actually give us a knowledge in the future.
This is really nice.
Okay, so we can say that for sure. And you're right. It's a recommendation. We shouldn't be wishy-washy. Could we simplify the rest to say some concerns have been raised that the skip and watch again options could complicate difficult tasks?
I think we can. I think it is important because otherwise it would be like suggesting to use it without telling any negative effects too.
Yeah, and we don't know if that.
There should be a warning of the other side of the coin as well, I think.
Yeah, I like it. It won't be as restrictive as we would like to have it in a recommendation.
But for now,
we don't have knowledge now, so it has to be like that. Yeah, exactly. Because all this work is because of you, Irena. Please.
I was wondering if there's any reference about the concern. If there was any paper with concerns for it.
I think it was generally rarely used beside of those work that is cited here and Dietman work that we don't have enough knowledge.
And also now I have another question, but maybe not the place to discuss this right now. Okay. This might also affect the tools that we use to detect outliers. So now the lack of overlap in the tools that has been tested commonly by the observer. if does any kind of observation has been done regarding to this. I don't know if it could impact it hugely, but it looks like it might at least start.
I don't know if we can spoil a lot, but it's not a problem.
Okay.
The outlier detection is not a
Okay. Okay, good to know. I don't have any.
Okay, the presentation earlier where the skip option was used, is there a publication we could reference?
Anyone? Do you know?
And it was a pairwise comparison, no?
Yeah, it was pairwise, not ACR. Right.
Is it within the scope of?
Yes, this is going to be an acceptable change to any method.
Okay. And
we would need that paper to have some statistics on frequency of subjects using the option.
Yeah, and we have no idea because Vietmar was really focusing on the method itself and how much how much this method allowed to see just noticeable differences, but not on this feature. And this feature was merely accidentally presented to us.
Okay, so it's not something we should add. For the counterexample to this I mentioned is described here. Okay, I will look through the paper after we're done talking and see if there are statistics. If there are, I will add it. If there's not, I will leave it out.
Sounds good.
In my experiments, at least 1/3 of subjects never used the skip option. And the highest rate I ever saw was one subject who used the skip option 10% of the time. Ignoring that one person, I would say the average person would only skip 1, 2, or 3 times out of 100 stimuli, and I never saw any patterns that people were skipping the same sequence. It really seemed to be my attention wandered. Okay, let's move on to the next. Oh, no, here's my actual written down statistics. Let's see, the longest test, 600 stimuli, 33% subjects never used. And the most used was 2.3% of those 600. The next test, 100 stimuli, but in a public environment, so people are kind of distracted. 68% never used skip, and that was the one with the 10% use of skip. And the third test I did, 100 stimuli in a public distracting environment, 76% of people never used skip. 6% was the most use of skip. And Werner's paper, it's on a 5-level scale, but his very inconfident and inconfident were 3.8% and 0.3% respectively. So I really saw no evidence of skip being abused.
Would be interesting to know if have you done that analysis if it leads to any more stable results, like let's say a lower confidence interval or something like that?
No, I did not.
Very few that uses skip option and it doesn't lead to more stable results. It may just complicate the whole procedure to have the skip option.
You're right, I didn't do that. For my 4 tests, these were 4-second stimuli, and I'm really concerned with that short of a stimuli that if you briefly lose attention, you won't see anything. I agree. It would be good to do an analysis and really see if it helps or does it complicate matters unnecessarily.
But most likely, like in a first choice test, there will be a choice, most likely 3, and then how so you would have like a random results which are in there, and that would possibly then make the confidence interval larger. Without, but on the downside, you would have like missing data in your analysis, which could, in some cases, make it worse to analyze.
Oh, it's impossible. You have a missing data that makes any analysis worse. But you know that someone didn't watch this sequence, so you can randomly generate the results. The analysis will be as good as.
Yeah, but what's the point then? I mean,
yeah, at least I know when I should randomly generate if the method needs it. But I know that this person didn't see this sequence.
Okay. Yeah. I mean, sure. I agree. That's more information that. At the cost of a more complex method.
It's true, and okay, I also agree that there is a little chance that it could have a influence on the result. But anyway, in my opinion, like it's a little bit strange that if we're really focusing only on the numbers and not on also on some, because there's yet this other factor that people maybe pay more attention to that, and this one we won't be able to detect more attention to a test where they know that there is skip option, so I can skip, but on the other hand, I don't want to overuse it because I was paid for test. And, and then after, well, I don't know. I wouldn't like to go for this guessing. Yeah.
I just looked at the Edwards paper, and there is a paragraph about not sure of the same as skip option. And he said the reference to that in data test, in conversion test, that adding this not sure option reduces subject stress but the first stress. And the second insight is that if you force participants per comparison experiments choose either left or without giving them an option to skip option, it may actually compromise the fair comparison efficiency.
Very strong, in my opinion.
Yeah, sure. I was you said not sure. Would that be the same as they give a number and say not sure, or they don't give a number and say not sure?
They don't give.
They don't
can
give.
either say the right image is better or the left is better. I'm not sure.
I'm not sure.
Okay, but that's kind of a more like a tie description rather than a skip. That they don't vote. In this case, they actually are saying that they cannot distinguish them, and that's my interpretation.
Yeah,
So,
but also it can be treated as they say not sure. We can discard the result and it will become skip option.
but skip option is, it could be that they didn't pay attention, but the not sure can be that they cannot tell them apart.
Yes.
Yes.
Do you have a reference for the paper that shows there's a change in results for 2-level forced choice pair comparison?
I mean,
based on
to
a skip option?
Nice. Go read the paper and see what it says. It's good that you found the reference. Yeah. So, but,
Yeah, I kind of remember hearing a talk years ago about the problem with using a skip or option on 2-level forced choice. But I'd feel more comfortable adding that if somebody could find a reference.
I'm pasting it in the Google.com right now.
And there is,
Thank you.
and also, I just want to make a small comment, but then I see that Babak has raised his hand. I was just, when I was, when we talked about this with the not sure and not, there could be like a third option here that you actually vote and then kind of rate your confidence level on your voting. Just throw that in there. But so Babak?
Yes, thanks. I have one question maybe and one suggestion. The question is about the difference between skip and watch again. I think the difference is that when we provide a skip, when we don't want participant to watch the video again, and because of whatever reason, either they couldn't decide, they were not concentrated, or what, they don't want to provide the answer, so we let them to do not mess up with our answers. But watch again is the case that we say is okay for us if you watch again, but we definitely want you to make a decision. And we don't want that kind of I don't know or what, I'm not sure. We want you to make a decision for that. And maybe it would be good if we put the distinction also somewhere and let the experimenter, based on the goals of the experiment, decide which one could be the most beneficial. The second point is about the statistics. Maybe rather than all of the numbers, we can say like if there's a participant that significantly more than the others are using this option, their response should be removed. And or if there's an item that or video clip that is kind of significantly more than the others are subject to skip or watch again, that should be also removed or considered again.
Okay, let's focus on the first feedback first. I like the idea of adding a sentence around it. So let me write it and then Babak read over and correct it. The watch again option ensures that each subject will view and rate each stimuli. I would like to say each stimulus. Some concerns have been raised that the watch again option may impact ratings.
So is there a concern? So is there someone worried about that? What are the cases?
Actually, yes, we saw that with the VQueg full reference phase 1 test. That one of the labs used a watch again option and the other labs did not, and we could see a difference in the ratings.
Yeah, in my opinion, watch again is different than skip. Because watch again can be used to, I'm not sure about the details, I want to watch it again in order to be able to answer more correctly. For some people that are very, they really want to be correct. And if you have an option to watch the sequence a couple of times before voting or just once, then it's a tremendous difference in terms of the scores. Just taking into account that some tests are forcing people to do it very quickly because they really want to see the first impression, especially in UX design. There are some tests, like there is this 1 second test or some things like that. So really, watch again, in my opinion, I would count it as a little bit more dangerous.
I think I agree with this comment. To me, it seems like it's almost, it's not as powerful as maybe a flicker test compared to a side-by-side comparison. Because with flicker, you can more easily notice differences. And I think it again have a similar effect, but maybe not at the same intensity. So it allows you to see better some differences, and you can see with just one single point. So I think it we treated carefully and warning.
Okay, how do you feel about the text as highlighted and written? I've changed the warning at the end to read, the watch again option may impact ratings because some subjects will watch again to check details.
Yeah, this would be much better. Just explaining why this is the dangerous option.
I'm a little bit biased because I normally use crowdsourcing and they are paid and they want to maximize their benefits. So they are really rare those cases that they watch again only because they want to be kind of true about the cases. But okay, maybe that also we can say that whereas a skip guarantee that they watch it once, and when they are not sure, they can just skip out of the giving the vote. So the experimenter decide by themselves which of those could be best for their goal of the experiment.
Yeah, I think so. I mean, the purpose of the test is very important. I think also for method like Sandvik, it's embedded in the method that you can watch again. So then you somehow are after that people can really do this distinction between them and so depending on what you want to achieve with the test.
But I think it is already good coverage of cases.
Yeah.
Okay, so is this wording okay? The skip option makes sure that each subject rates each stimulus after viewing it only once. We could move this to the end of the watch again paragraph and say, by contrast, the skip option makes sure that each subject.
If you move
Sorry, I couldn't hear.
I think it's better if you move it to the end, as you suggested.
Yes, I like it better there too. Okay, and Babak, I've lost track of the second issue you raised. I'm sorry, could you repeat it?
Yeah, maybe if you scroll down to the after the references, do you want to put all of the numbers in the recommendation?
We could. My thinking was no, just put the references in, and this was just to support in the contribution to support the addition of the skip option.
Okay, that makes sense. If we want to have a kind of a specific suggestion what to do when it is happening, we can add the sentence that if there is a significantly misuse of the option, like someone is significantly using that more than the other participants, then the experimenter can remove that participant. But I think it's a kind of self-explanatory. Everyone should do that when they analyze the data.
I will object that wording because I want to know what is significant when someone says significantly. If you use that, I think we should also define the significant.
Yeah, for me would be also a kind of extreme outlier if we just make a box plot or whatever approach, if it is a outlier based on the performance of or the number of time the others are doing it.
Yeah, But anyway, I would leave the decision about skipping to like not putting it into a standard, because what is the point anyway? We can pretty trust the rest of the answers given by the person that skip 50% of the sequences, yeah? Because using the skip option proved that not using probably answer the correctly, yeah. Yeah, maybe in crowdsource it's a different story if someone is clicking randomly, but it's difficult to say.
Yeah, that's true. That's for crowdsourcing. We have completely other stuff.
Mm.
So Shelley, you're pointing out that the rating of confidence of the vote, the approach that Werner used, maybe we should list that separately.
Yeah, I mean, it's something in between the skip and watch again. Did Werner have have tested that, or?
Yes, the paper, this reference to his paper in 2014, people rated each stimulus both on a 5-level ACR scale and on a 1 to 5 scale. How confident are you in your rating?
Okay, yeah. Oh.
And my hesitation with that approach is that it wasn't clear how to analyze those results. What do you do with it? Where the skip and watch again are very straightforward for somebody doing a test. That's not an objection, just I think it's going to be harder to work.
They didn't have like, so how did they analyze the data? I mean, I wasn't aware of this, but maybe I thought of it, but maybe this was because I heard it before. But wouldn't you just do some sort of a weighting on the based on the confidence? I mean,
well, I think you certainly could. I'm just hesitant to recommend that in a standard when we've not tried it out except once.
Yeah. Or so maybe I can have a look and see if there has been. It doesn't seem to be that unique idea, so maybe it has been used before, and if it hasn't, maybe just a conference paper is not enough for. So I don't have a strong opinion to put it in. It's nothing that I'm used myself, so maybe Werner should argue for it instead. I think it could be reasonable, but maybe, as you say, we don't have so strong kind of reference and experience of it. Anyone here that has used this type of approach?
Confidence rating along the...
Yeah,
the test person will give the rating, and then it kind of judge their confidence in their rating.
So it's not the example from our discipline. Me and Lucia had multiple discussions with psychologists, and in psychometrics they use this approach, which is based on signal detection theory. That's the keyword. And there, this theory actually comes from telecommunications, but this is irrelevant. There you give a score plus confidence. And in psychometrics, this is a pretty popular measure. I also like to reference confidence, but of course, this is far beyond multimedia quality.
And then all the data analysis is very different.
Yes, but it is used.
Yeah. Okay. But then maybe this relevant. I mean, if it's used in psychology.
But if we want to change this standard during this meeting, like this proposal, I wouldn't involve that. Yeah. Because this would need really
okay.
much more.
Yeah. You have a point.
Even reading is not enough. We need to maybe replicate this
Yeah.
with this method and see how it goes.
Yeah,
at least once before doing it.
Good recommendation. It's a very wise proposal.
Okay, yeah, maybe we keep it in the bucket for for the next revision.
Okay, I have no objections if somebody actually knows the details of what we should say and is willing to propose text. IT recommendations take a long time to approve. It's not like you would need to rush.
And I guess this is still something we would just, I mean, we would send this in as a contribution. I mean, the actual text that would be changed would be decided by the ITU. So they
Yes.
may not put in all of our suggested changes anyway.
Exactly. And there may be rewordings and other changes that happen as part of that study group 12 process.
Okay, yeah, but maybe we could. I don't have a good text at this point, so maybe we.
Okay. Okay. So clause 9.1, number of subjects currently reads as the first paragraph that the number of subjects in an experiment can be reduced if each subject scores each PVS multiple times. One rating from each of 24 subjects should yield approximately the same accuracy as 3 ratings from each of 9 subjects. This technique would be appropriate when the goal of the experiment is to characterize differences among subjects. And the changes, I'd like to explicitly add the for method to P913 instead of it just having this one brief paragraph. So I want to add a new clause 9.5 that describes the for subject protocol as part of the recommendation, gives information describing its use, and pull it out of section 9.1. So instead, 9.1 would just say the number of subjects in an experiment can be reduced if each subject scores each PVS multiple times. For such purposes, it is recommended to use the for subject protocol as described in clause 9.5, and then 9.5 would read as follows here. And this is all taken from the paper that Lucian and I did with Pablo and Narciso. I don't know, how are we doing on time, Shell?
We probably would like to end around 6 our time, so in 7 minutes. I don't know how with the. Do we have anyone knowing about the transportation to the social event?
I heard people discussing car, but
so when are we leaving for the social event? I guess there is no time to go back to the hotel in between. No, I mean it's just a practice. We know where we. What time we have to be at the... It takes half an hour to go there, right?
It takes half an hour.
Yes.
So we have still from half an hour.
Yeah. Okay, so it seems that we have about half an hour.
No. Okay.
But we should probably, I mean, if it takes half an hour to go there, we should stop at least quarter past so we can move our bodies into the cars. That's 15 minutes at least. So maybe we should stop earlier than that. We are
Okay.
kind of slow.
Okay, let me cover quickly, and let's not look at the text necessarily in such detail as we have been. We're going to continue discussing these changes during the next SAM meeting or a future SAM meeting until we're happy with the text. We've gone over the text before this point during a previous SAM meeting, and from this point forward, it hasn't been looked at yet. So I'm expecting we'll need to have at least some discussions at a SAM meeting. So the one whole idea is to add the forward protocol explicitly by name with enough information that a person would understand when to apply it and why they would like to apply it. And the group has heard about the forward method a couple times in previous meetings. So before we, are there any general comments before I show what's the next topic?
I don't see any in the room, and not.
Okay, and to point out the part of the text that's going to need the most close scrutiny is this paragraph here, which talks about when you would want to apply the forward method and why. Where the previous is above and below is saying limitations based on approach and what you do. Okay, the next clause is on a conventional, which is to say full matrix experiment design versus the unrepeated scene designs that Lucian and I proposed, and we've heard many other talks at VQuag use these unrepeated scene designs. And we now have enough information from this sort of design being applied that I think it ought to be mentioned in P913 and give people some information and context. At this high level, is there any discussion?
Did you raise your hand, Jacob, or no? So I don't see anyone having anything to say at this point. You can go on.
Okay, and as part of this unrepeated versus conventional scene design, I thought it would be nice to add the equation that the VQuag evaluations concluded about the relationship between video quality, audio quality, and the overall audiovisual quality, since P913 includes audiovisual testing. And the last is another area where there's likely to be more discussions and edits. And this has to do with using a confusion matrix to measure the disagreement rate as a way to understand lab-to-lab or method-to-method comparisons. So that is instead, traditionally we've been using Pearson correlation when we compare one lab result to another or one method results. And this is saying, here's the confusion matrix in the picture here. And the key one is disagreement. What's the rate that we will have? Subjective test 1 says stimuli A is significantly better than stimuli 2, but subjective test 2 says stimuli A is significantly worse than stimuli A. That's this box here, or the reverse up here. And that this disagreement rate is really the most offensive and therefore a suitable way to compare lab to lab or method to method to understand what's going on. And then there's two statistics that we pulled out of my analyses based off of 60 more. It's more than 60 now. I've gotten data from a few more comparisons, and lab to lab, method to method, and I even found 8, I think it is, comparisons between naive and expert subjects. And so this is recommending that anything above 0.31% disagreement rate is unusual enough to warrant further investigation, and anything above 1% indicates some sort of a genuine difference in methodology.
Yeah,
At this high level.
So, Lucian, did you have a comment?
Yeah, just to remind people who didn't attend the SNAP session, the concern that was raised was that a lot of different tests here. Still, we don't really know if the number. Yeah, the number is like practical observation of very many tests. Good in you could get this number from some statistical, and that's what we need.
I can tell that you're talking, Lucian, but I missed part of what you said. Could you speak louder and say it again?
I just wanted to explain to the audience here, to the people not presented at the SAM when we had the discussion.
Okay.
What was the concern during the SAM session? Didn't add anything new.
I think you can continue, Mark.
Okay, this is the last topic. So before going into the little bits of text that I think are most critical, I would like to hear from people if there's any other topics I've missed. An area that we've recently learned more about how to do subjective tests that it might be suitable to include in P913.
Anyone? Don't see anyone at this point having anything to add.
Okay, the one area I considered was tests like the quality for assessment for health applications is picking stimuli that depict a particular task. And if there's enough we've learned there to comment on that issue. I did this with the ACR scale for public safety, and I'm very happy with the results. I think I really pulled out some trends from that, the needs of those people using the same standard methods. And is there anyone else?
Could you please repeat the procedure, because I didn't get it?
So I used the 5-level ACR test, and the only accommodation I made for public safety is I picked images or videos that showed their tasks and the impairments they encounter. And during instructions, I asked people to, as they were using the ACR scale, to keep in mind they are rating the quality for that task. Say, search and rescue, or using photographs from a crime scene, for example.
I understand that another example that could be set that is a little bit in this direction is the test done by Netflix with also Patrick Group, where they like thought about that this is a service that I pay or the service that I don't pay for. And then they, instead of, they changed the ACR scale to something else, to the acceptance. but this would be this direction, like describing the task before someone is scoring.
Yes. So describe the task and then give media that are appropriate for that task. And as an alternative to P912, which has a much more complex methodology, where you need to be able to, say, identify objects, read license plates, or so on, that's a much more complex subjective test than doing a standard ACR test.
Yes, I agree with you, Margaret. So in the medical case, for instance, as I mentioned earlier times in BQAG, what we ask medical doctors when they assess possibly impaired images, if they would feel confident performing a diagnosis based. So this is in line with what you mentioned with the first responders. It makes sense to add something about the question which is presented to the subjects.
Okay, and Maria, I don't remember without looking it up. Did you use a 5-level scale?
We did, yes.
Okay, so it sounds like that's 3 examples we came up with fairly quickly where people have successfully used this approach. Let me add just the bare bones. And Maria, could you insert a paper?
Yes, I'm looking for a suitable one now. For instance, we had the paper in 2014 using this method, but I will check if I mention the question in that one. Otherwise, I will look for another one. I'm doing it.
Okay. Thank you. And Lucian, is there a paper for the Netflix study that you could easily find?
Yeah. Yeah, Patrick said that he will send the paper. So please do so.
Okay, and I will add something for public safety. And I'll have to propose, I'll write the text when we're done. I don't want to slow us down here. But it will basically be describe 2 issues. First, that the instructions describe the task. And the second one is that the stimuli are appropriate for that task. And I'll write that part later. Are there any other examples that people in the audience could mention we can use for this?
Just speak because there's no camera.
I know, but I don't have any other.
I think similar to the Netflix study, once we asked the subjects about their willingness to pay for a specific improvement or service, but this is similar to the Netflix one. If you wish, I can look for the reference for that work. Probably similar to the Netflix use case.
Yes, take your time.
And I've added in the meanwhile the medical.
Okay. Well, that is pretty much our time. I would rather close here and give over time for looking at minutes.
Sounds good. Okay. So is there any final comment to Margaret about her qualification document. Jacob?
I have one last comment. As far as I remember, I may be wrong here. I know that the recommendation asks researchers to check whether participants are naive participants or experts. And I'm wondering if recommendation asks researchers to check and report on whether people previously participated in this kind of experiment or in any other experiment.
Yeah, this is a very good comment, actually. So, for instance, in our case, both for gaming and the medical case, we need to be informed on the expertise. That's a very good comment. I agree with it.
You know, I don't remember.
Many people prolific testers. So 10 people come to the laboratory, and if you do not ask them explicitly, have you ever been here before? They will not tell you that, or they only tell you by accident.
There were some wording in previous recommendation that the naive observer should not have participating at least for the last half a year, as far as I can remember. So that's
There are two levels of being naive, right? One is being, let's say, new to subjective tests, and one is being new to the content. So on. In some cases, for instance, we split groups between those who are familiar with the content and those who are not.
I just want to comment that I will be very strongly against saying that we need naive testers that never participate in the study, because then probably we won't be able to make any study. Beside those people that do it like professionals, like do a lot of tests, simply nearly no one is coming because.
But you have a lot of students at AGH, right?
Yeah, and they're not interested in.
You are not paying them enough.
You could consider compensation.
Yeah. No, really, computer science students. Yeah, we cannot.
Coca-Cola. Okay. You just need to give them Coca-Cola.
I guess I would need to pay as much as I pay for the professional.
Yeah, perhaps. No.
Okay, I can find the answer and not necessarily make any recommended changes, but I'll find the answer.
Okay, then I think we should close this this session and approve the minute for what?
There is a minus a link, but it is not accessible for us. And I was just today
Right, a good point. Margaret.
So this
Yeah.
Yes.
The document link Google Doc that you prepared for minutes have not been accessible. So we created we created a new Google document where we have recorded the minute. So I will paste the link in the chat, and maybe you can update the link on the homepage with the new document.
Okay. I will do that, and thank you. My apologies for that. I'll make this change, and some of the other website changes, I've been waiting a day or two while the software supporting our website is being updated.
And Shirin, you wanted another document. Is this you mean this document we have edited?
This document and the minutes that we used during these days.
The minutes.
The minutes.
Yeah, that we took care of now. But so okay. So is there somewhere? I mean, the document that we have been editing now. There is a link in the chat. Okay, right. Okay, great. Okay, so let's close this session, and I will share the screen with the minutes, and we can try to approve them, and then we close for today, and we should be able to get to the cars in time. So jump down to the day 3. Also, yeah, when I saw a comment there, just Margaret, you emailed me in the morning saying that maybe you've already said it, but there is some kind of software update on the whole page, and
Yes.
that some updates are being postponed after the software change. Especially.
Yes, so the software that's supporting the VQuag website is being replaced. And as part of that update, the anonymous VQuag FTP is going away. Anonymous FTP is in general obsolete and considered a security risk by pretty much everybody. So the meeting files and project files will be embedded into the new VQuag website, which will look almost exactly like the old one. My IT team needs maybe one day, maybe a couple days to finish that up, and then everything will be ported over. So there's a couple changes. I'm just waiting till that finishes.
Okay, thank you. So day 3, we had an update from the ITU by Julie and Alexander about the work going on in the ITU. Then we did some schedule changes, so we went directly into the IMG where Shirin gave a presentation. We continued. We had a picture session. Maybe we don't need to record that. Where are the pictures? Are they already?
We will receive the pictures tomorrow.
Ah, okay. Looking forward to that. So we had a presentation by Pablo and Jacob is writing. So you want to ask him a question, or?
No, it's more like a comment.
Okay. Right. Okay.
Maybe a question after all.
Yeah. Is there an action for him on that? So how do you want that to be handled? I mean,
I can have Jesus here and ask him to consider the question.
Okay, yeah, please do that. Presentation by Ali and Wakas, and then Irene made an advertising about the workshop. And then we went on to the QAH, some presentation, continuing with Norm. There are no decisions so far, so not so. So if you see something you would like to update, so please yes, tell me. Can we approve the minutes? Okay. Minutes are approved. And we are closed for today. Thank you so much for all your good inputs and hard work.
Thank you. Thank you. How many cars we have?
Okay, thank you also online. See you tomorrow at 9 o'clock at least.
And half at some place for
Oh.
Oh, yeah, right. There is the social tomorrow. So when, I mean, for the online, so when are we actually back here? I know people are leaving, but we should probably post some things to tell exactly. So how is it planned with the are we back here?
No, tomorrow morning.
Well, tomorrow morning we are not here.
Yeah.
But then when are we back to start
I
here?
think 2 o'clock or 1:30 because one and a half maybe.
Yeah.
Because tomorrow the lunch is free and the guided tour will be finished by 11:30. I think.
Okay, and then we go directly to lunch
And
at the same place as we are.
maybe yes, in the city center.
Okay.
So free lunch tomorrow. Everyone will.
Okay, that sounds great. Okay, so I think that would work. Being back here at 1:30. So
Yeah, I hope so.
Yeah.
I think.
Okay, I have an announcement on the VQuag webpage switchover. I'm going to schedule it for what's 11 o'clock in my time zone, so the next hour, 40 minutes from now.
Okay.
So everything will be down for maybe 3 minutes at that time.
On the website.
Yes, the website will be unresponsive for about 3 minutes.
Okay, I think we can live with that. Thank you. Okay, so bye, Margaret, for today. Talk to you tomorrow.
Bye. Thank you.
Bye.
So what time we're starting tomorrow?
Yeah, I think the program 1:30 or 2. I mean, it's not completely clear because we haven't been. It's kind of we should arrive here after lunch, but we have been going. Being back time have been a bit flexible. So I think at least we need to leave at 6:30 with the train, so we cannot tomorrow. I leave tomorrow. Yes. We rescheduled the Friday.
Yes, but okay. For you.
But yeah, but I told them so. So I hope she changed the book.
It's not
No, my original plan was we stay after and go back during Friday, but then we thought of